Subscribe so you don't miss out on any of these videos. The cosmos is filled with enigmas that challenge our understanding of the universe, but few are as perplexing and awe-inspiring as the mystery of Eta Carinae. A star system unlike any other, it has defied expectations, survived catastrophic eruptions, and continues to shine with an eerie brilliance that astronomers struggle to explain. At the heart of this mystery lies a question that has haunted scientists for centuries. Why does Eta Carinae refuse to die? In the vast tapestry of the universe, where stars are born, live, and inevitably fade, this celestial giant seems to have rewritten the rules of stellar evolution. What makes it so special? Why did it erupt so violently in the 19th century, only to endure? And could it be on the verge of an even greater cataclysm that will leave an indelible mark on the cosmos? This is the mystery of Eta Carinae, a star system that challenges everything we know about the life cycle of stars. Eta Carinae is a stellar system approximately 7,500 light-years from Earth in the Carinae constellation. It is one of the most luminous and massive stellar systems known, harboring at least 2 enormous stars that orbit each other in a tight celestial dance. But what makes Eta Carinae so unique is its explosive past, specifically, an event known as the Great Eruption of the 19th century. In the mid-1800s, Eta Carinae underwent one of the most extraordinary outbursts ever recorded, temporarily becoming the second brightest star in the night sky, outshining all other stars except Sirius. For a brief moment in history, it was an object of wonder and fear, a glowing beacon that could be seen even during daylight hours. But what exactly happened during this eruption, and why did Eta Carinae not follow the typical path of stars that undergoes such violent upheavals? To understand the significance of this eruption, we must first delve into the life cycle of massive stars. Typically, stars of great mass burn through their nuclear fuel at a furious rate, eventually exhausting their energy reserves and undergoing a supernova explosion, leaving behind either a neutron star or a black hole. However, Eta Carinae defied this expectation. Instead of a supernova, it experienced a so-called supernova imposter event, an outburst so intense that it ejected an enormous amount of mass into space but failed to destroy the star itself. This eruption released an estimated 10 to 40 times the mass of our Sun in a violent outflow, creating a spectacular nebula known as the Homunculus Nebula. Today, this nebula remains one of the most iconic features of Eta Carinae, glowing with an eerie luminescence as a reminder of the star's turbulent past. But the real mystery is why Eta Carinae survived. Conventional models of stellar evolution suggest that an explosion of this magnitude should have marked the end of the star's life. Instead, Eta Carinae persisted, albeit with significant changes. The star system dimmed after the Great Eruption but never fully faded, continuing to shine with remarkable luminosity. In the years that followed, astronomers observed strange fluctuations in brightness, suggesting that the system remained highly unstable. Even today, Eta Carinae is surrounded by clouds of mystery, both figuratively and literally, as its vast shell of ejected material continues to expand, revealing secrets about the chaotic physics at play. One of the most intriguing aspects of Eta Carinae is the nature of its binary companion. The primary star in the system is an extremely massive and unstable luminous blue variable, LBV, a type of star prone to sudden and dramatic outbursts. However, it is now widely believed that Eta Carinae harbors a second massive star, possibly even more massive than the first, locked in a highly elliptical orbit. This companion is thought to interact gravitationally with the primary star, influencing its outbursts and contributing to the erratic behavior of the system. Every 5.5 years, the two stars come perilously close in their orbit, creating extreme conditions that lead to violent stellar winds and intense radiation bursts. Another major puzzle surrounding Eta Carinae is the presence of highly energetic X-rays and gamma rays. Observations with modern space telescopes, such as NASA's Chandra X-ray Observatory, have revealed that the system emits intense high-energy radiation, far beyond what is expected from a typical massive star system. This suggests that powerful shock waves are occurring within the nebula, potentially caused by the collision of stellar winds from the two massive stars. These winds, traveling at speeds of thousands of kilometers per second, create a turbulent environment where matter is constantly being accelerated and ejected into space. The future of Eta Carinae is another profound mystery. Many astronomers believe that it is still on the brink of an inevitable supernova, an event that would mark the final act in its long and chaotic life. Given its extreme mass, Eta Carinae is a prime candidate for a hypernova, a more powerful version of a supernova that could release an immense amount of energy. Some even speculate that the explosion could result in the formation of a gamma-ray burst, one of the most powerful and destructive phenomena in the universe. If this were to occur, it could have far-reaching consequences, potentially affecting Earth if the gamma-ray burst were directed toward our planet. Yet, despite the expectations of an imminent collapse, Eta Carinae continues to defy predictions. Decades have passed since the Great Eruption, and the star system remains active, unstable, and unpredictable. Some astronomers argue that it could undergo another supernova imposter event before its final demise, experiencing additional eruptions that further shape its surrounding nebula. Others believe that the presence of its binary companion could delay the inevitable, extending Eta Carinae's life far beyond what would be expected for a star of its size. One thing is certain, Eta Carinae is not a typical star. It exists in a state of cosmic defiance, challenging our understanding of stellar evolution and pushing the boundaries of astrophysical theory. It is a relic of a bygone era, a stellar titan that has survived cataclysms that would have destroyed most other stars. It is a time capsule of cosmic history, holding within its turbulent heart the secrets of the most extreme processes in the universe. And as astronomers continue to observe it with ever more advanced telescopes, we may one day unlock the final answers to its mysteries. For now, Eta Carinae remains one of the greatest enigmas in the cosmos, a star that refuses to die, a beacon of celestial defiance, and a reminder that, in the universe, the most extraordinary phenomena often lie in the most unexpected places. The mystery of Eta Carinae deepens when we consider its past. While the Great Eruption of the 19th century is the most well-documented event in its history, evidence suggests that this star has experienced multiple outbursts throughout its lifetime. Astronomers studying historical records and ancient observations have found hints that Eta Carinae may have undergone similar eruptions in the past, albeit less intense than the one in the 1800s. These smaller but significant outbursts could indicate that Eta Carinae is caught in a cycle of instability, where its internal pressures periodically reach critical levels, leading to violent expulsions of mass. But if this is the case, what is driving this cyclical behavior? The answer may lie deep within the core of Eta Carinae. Massive stars are governed by the delicate balance between the outward pressure of nuclear fusion and the inward pull of gravity. In normal stars, this balance is maintained until the nuclear fuel is exhausted. However, in extreme cases like Eta Carinae, the forces at play are so immense that even small disruptions in the core can lead to catastrophic eruptions. Some astrophysicists theorize that Eta Carinae's instability is caused by helium shell burning, a process in which helium fuses into heavier elements in a sudden burst of energy. This could create rapid fluctuations in pressure, leading to dramatic ejections of material. Another possibility is that Eta Carinae's binary companion plays a significant role in its unpredictable behavior. If the companion star is in an eccentric orbit, its gravitational influence could periodically disturb the primary star's outer layers, triggering eruptions. Observations suggest that each time the two stars reach their closest point in orbit, the system undergoes significant changes in brightness and energy output. This suggests a direct correlation between their orbital mechanics and the eruptions of Eta Carinae. However, the exact nature of this interaction remains an open question. Is the secondary star actively stripping material away from the primary, or is its gravitational force simply destabilizing the outer layers? The Homunculus Nebula, the vast shell of gas and dust surrounding Eta Carinae, offers further clues about the star's past. This nebula, formed during the Great Eruption, continues to expand at incredible speeds, providing a unique laboratory for studying the dynamics of massive stellar explosions. Observations have revealed complex structures within the nebula, including dense lobes, shock waves, and regions of high-energy radiation. These features suggest that the eruption was not a simple event but rather a highly chaotic and multi-phased explosion. One of the most surprising discoveries within the Homunculus Nebula is the presence of nitrogen-rich gas. This indicates that the material expelled during the eruption came from deep within the star, suggesting that the explosion was powerful enough to dredge up material from the core. This is unusual for a star that has not yet gone supernova, further complicating our understanding of what exactly happened to Eta Carinae in the 19th century. Modern technology has allowed astronomers to study Eta Carinae in greater detail than ever before. The Hubble Space Telescope and the Chandra X-ray Observatory have provided breathtaking images of the star system, revealing intricate patterns of light and energy. Infrared observations have shown that the system is still actively shedding mass, indicating that Eta Carinae is far from stable. Additionally, radio waves detected from the nebula suggest that strong magnetic fields are at play, which could be influencing the system's behavior. One of the biggest questions surrounding Eta Carinae is when, or if, it will finally go supernova. Given its mass and instability, it is almost certain that the star is in the final stages of its life. However, predicting the exact timeline of such an event is incredibly difficult. Some estimates suggest that Eta Carinae could explode within the next few centuries, while others argue that it may hold on for thousands of years. When it does finally reach the end of its life, it is expected to produce one of the most spectacular supernovae ever witnessed by humanity. If Eta Carinae does explode, it will have profound implications for our understanding of stellar evolution. A supernova of this magnitude would provide astronomers with a rare opportunity to observe the death of a massive star in real time, offering invaluable data on the processes that govern the formation of black holes and neutron stars. Additionally, if Eta Carinae produces a gamma-ray burst, it could briefly outshine the entire Milky Way galaxy. Despite its distance of 7,500 light-years, a supernova from Eta Carinae would be visible from Earth with the naked eye. It would likely appear as a bright new star in the sky, rivaling the brightness of the Moon for a short period before gradually fading. However, while the explosion would be a spectacular sight, it is unlikely to pose a direct threat to Earth. Astronomers believe that the gamma-ray burst, if it occurs, would be directed away from our planet, sparing us from its potentially devastating effects. Still, the idea of Eta Carinae as a cosmic ticking time bomb continues to fascinate scientists and skywatchers alike. It is one of the few stars in our galaxy that could realistically undergo a supernova within human history, making it a prime target for continued observation. As we look to the future, new telescopes such as the James Webb Space Telescope and upcoming ground-based observatories will provide even more detailed insights into Eta Carinae's structure and behavior. These observations may finally help answer some of the lingering questions about its past eruptions and its ultimate fate. Yet, for all that we have learned, the mystery of Eta Carinae remains unsolved. It is a star that should not exist in its current form, a survivor of a cosmic catastrophe that defies logic. It stands as a testament to the unpredictable nature of the universe, reminding us that even the most well-understood scientific principles can be challenged by the raw power of nature. Eta Carinae is more than just a star. It is a symbol of the unknown, a beacon of celestial mystery that continues to captivate the imagination of astronomers and space enthusiasts alike. It may one day provide us with the key to understanding some of the most extreme forces in the cosmos, or it may continue to defy explanation, remaining one of the greatest unsolved enigmas in the universe. As we continue to observe Eta Carinae, the star remains an important touchstone for scientists studying the life cycle of massive stars. The processes that govern its instability have profound implications not just for our understanding of individual stars, but also for the broader dynamics of star systems and galaxy formation. Eta Carinae offers us a rare window into the explosive final stages of a star's life, stages that, under different conditions, could lead to the formation of one of the most powerful cosmic objects, a black hole. The relationship between massive stars and black holes is one of the most fundamental areas of research in astrophysics. Understanding how stars like Eta Carinae transition into black holes helps to inform our knowledge of how supermassive black holes, which reside at the centers of galaxies, might form. These black holes likely result from the collapse of stars many times the mass of the Sun, much like what Eta Carinae might eventually undergo. However, the specifics of this process remain unclear. For example, it's still uncertain how the core of a massive star can collapse without triggering an event that causes the star's outer layers to be expelled. In some cases, this leads to the creation of a black hole. In others, the star may not have enough mass to form a black hole and will instead result in a neutron star or another dense object. In this context, the great eruption of Eta Carinae becomes even more interesting. Could the eruption be an attempt by the star to shed enough mass to avoid collapsing into a black hole? Alternatively, might it represent a more extreme phase in its evolution, one where it is on the verge of becoming a black hole but has yet to do so? The violent outburst could be a desperate attempt by the star to shed enough material and reach a more stable equilibrium. However, in all likelihood, these eruptions only prolong the inevitable, a spectacular and highly energetic supernova explosion, which could herald the birth of a black hole. The possibility of Eta Carinae collapsing into a black hole also raises important questions about the nature of the star's binary system. Its companion star, although not as massive as Eta Carinae itself, still exerts a gravitational influence over the system. As these two stars orbit one another, they exchange mass and energy, a process that further complicates their evolution. The companion star may eventually accrete enough mass to become a significant force within the system, potentially influencing the outcome of the star's final moments. Would Eta Carinae become a supernova before its companion star has the opportunity to merge with it? Or could the two stars collapse together, resulting in a dual black hole system? The complex interplay between these two stars remains a topic of intense debate among astronomers. One of the most intriguing aspects of Eta Carinae is the way its mass loss is structured. The Homunculus Nebula, which is the result of the Great Eruption, contains a wealth of information about the mass ejection process. The structure of the nebula itself is not uniform. Instead, it contains lobes, filaments, and other intricate patterns that suggest that the eruption was highly asymmetric, not just in terms of its outward explosion, but also in the distribution of mass ejected. This asymmetric mass loss could indicate that the star's internal structure is not uniform, with certain areas of the star being more prone to eruptions than others. These fluctuations in mass ejection could play a key role in shaping the star's eventual fate. At the core of these outbursts, researchers also look for clues about the dynamics of massive star systems. In other systems, massive stars lose significant portions of their mass in the form of stellar winds. These winds play a crucial role in regulating the size and temperature of the star. In the case of Eta Carinae, however, the outbursts seem far more chaotic, with vast quantities of material being expelled at irregular intervals. This suggests that the mass loss is not simply the result of a steady stellar wind but is more likely a byproduct of the star's internal instability. Each eruption could represent a reset of sorts, where the star sheds material in an attempt to regain equilibrium. What's more, Eta Carinae's very location in the Carinae Nebula is key to understanding how this star interacts with its environment. The Carinae Nebula itself is a site of intense star formation, filled with young stars and vast clouds of gas and dust. The energy emitted by Eta Carinae's outbursts interacts with the surrounding nebula, potentially triggering the formation of new stars and even influencing the nebula's evolution. This mutual interaction between Eta Carinae and its surroundings is a crucial aspect of the broader life cycle of massive stars, where the explosive death of one star can serve as the catalyst for the birth of others. As astronomers continue to study Eta Carinae, it remains a model for understanding the late stages of a star's life. Stars like it are relatively rare, and their life cycles provide essential insights into the processes that govern star formation, evolution, and death. Moreover, Eta Carinae is also an excellent test case for understanding how astronomers can study distant, enigmatic stars that exhibit such extreme behavior. Advances in observational technology, such as space-based telescopes, allow scientists to observe these phenomena from unprecedented angles, collecting data that might one day answer questions about the true nature of the universe. The future of Eta Carinae is uncertain, but it's a star that has defied expectations throughout its history. Whether it eventually collapses into a black hole, creates a supernova, or follows an entirely different evolutionary path, Eta Carinae is a testament to the unpredictable and awe-inspiring nature of the cosmos. Its enigmatic eruptions, combined with its status as one of the most massive stars known, will continue to captivate astronomers for generations to come. Ultimately, the mystery of Eta Carinae is a story that's far from over. As the star continues its unpredictable journey through the cosmos, it offers a tantalizing glimpse into the extreme ends of stellar evolution. Its future may be uncertain, but the knowledge that we can observe its every move is a testament to the power of modern astronomy and our ever-growing understanding of the universe. Every observation brings us closer to unlocking the secrets of Eta Carinae, and every new discovery has the potential to rewrite what we know about the fate of the most massive stars in our galaxy. The scientific community continues to be captivated by Eta Carinae's extraordinary behavior and unpredictable future. The way it defies conventional expectations about stellar life cycles makes it a stellar laboratory for astrophysicists and observers alike. While many stars of its mass and type eventually exhaust their fuel and enter a supernova phase, Eta Carinae has proven itself to be an anomaly, a star that refuses to follow a predictable path. Its multiple eruptions, including the Great Eruption of the 19th century, suggest that there may be aspects of stellar evolution that we are yet to understand fully. In addition to its baffling behavior, Eta Carinae's position in the Carinae Nebula places it in one of the most dynamic and active star-forming regions of our galaxy. The Carinae Nebula is home to many other massive stars, some of which may go through similar evolutionary phases as Eta Carinae. In fact, studying Eta Carinae in this context has led researchers to reconsider their understanding of how massive stars interact with their environment and influence the formation of other stars. This interaction is one of the defining characteristics of star-forming nebulae, where the energy and material ejected by dying or unstable stars can trigger the formation of new stellar bodies, creating a never-ending cycle of creation and destruction. But it is not just the star itself that fascinates astronomers. It is the entire system. The binary nature of Eta Carinae, with its massive companion, complicates its evolution even further. The gravitational influence between the two stars affects their behavior in ways that are not fully understood. While the companion is not as massive as Eta Carinae itself, its presence still plays a significant role in the system's dynamics. The binary orbit, which is eccentric, might be responsible for some of the periodic outbursts of material from the primary star, as the stars pass closer to one another, triggering changes in the stability of the system. Some theorists speculate that Eta Carinae may be in the process of stripping material from its companion star, while others argue that the outbursts are merely a result of the intense gravitational interaction between the two. As we learn more about this complex system, we may come to realize that Eta Carinae's behavior is not merely a result of the star itself, but of the intricate dance between it and its companion. The massive amount of energy emitted by the star system, whether through radiation, stellar wind, or gravitational waves, affects its surrounding environment in significant ways. Eta Carinae's energy output is powerful enough to shape the very structure of the Carinae Nebula itself. The region surrounding the star system is filled with complex structures created by the intense radiation and stellar winds of Eta Carinae. The nebula itself, illuminated by the star's brightness, is one of the most well-known objects in the night sky, and yet it is also an active laboratory for studying the interaction between stars and their environments. The nebula is constantly in flux, with regions of gas and dust being compressed by the pressure of the star's radiation, triggering the formation of new stars. As Eta Carinae continues to shed its mass, it creates a feedback loop within the nebula. This mass loss enriches the surrounding gas and dust, providing the raw material for new stars to form. However, this feedback is not always positive. As a massive star loses material, it can also destabilize the surrounding region, leading to violent turbulence and shocks that disrupt star formation. This delicate balance between star formation and destruction is a key part of understanding the life cycle of a star, and Eta Carinae, with its immense power and instability, provides a crucial piece of the puzzle. The study of the star's outbursts and their effect on the surrounding nebula could give us new insights into the way stellar winds, magnetic fields, and radiation pressure influence the birth of new stars. This feedback mechanism is an essential part of galactic evolution, shaping the way galaxies like our own evolve over time. In some ways, Eta Carinae's outbursts serve as a warning to us. While the star itself is located a significant distance away, 7,500 light-years, its behavior offers us a glimpse into the catastrophic events that can occur at the end of a massive star's life. The enormous energy released during an eruption, or during the eventual supernova, serves as a reminder of the power that lies within the universe's most extreme phenomena. The process of stellar death is not a gentle one, and it can have far-reaching consequences. A supernova from Eta Carinae, for example, could send shockwaves throughout the surrounding region of the Carina Nebula, impacting other stars and possibly triggering the formation of even more stars. In this sense, the death of one star could give birth to many others. However, the possibility of a supernova from Eta Carinae also serves as a point of concern. If a gamma-ray burst were to be emitted from the star at the time of its explosion, the effects on Earth could potentially be catastrophic. While such an event is unlikely to be directed toward our planet, it is not outside the realm of possibility. Gamma-ray bursts are capable of stripping away the Earth's atmosphere, leading to mass extinctions. Thankfully, the geometry of the explosion, coupled with the star's distance from Earth, makes this a highly improbable scenario. Nevertheless, the fact that Eta Carinae is one of the most energetic stars in our galaxy reminds us of the powerful, and sometimes dangerous forces that exist in the universe. The potential for an explosive death, followed by the formation of a black hole, raises an important question: how do these supermassive objects influence their surroundings? Black holes, especially supermassive ones, can have profound effects on their host galaxies. Their immense gravitational pull can influence the motion of stars, gas, and dust in their vicinity, potentially reshaping entire regions of space. Eta Carinae's eventual collapse into a black hole could offer a unique opportunity to study the formation and evolution of such objects in real time. By observing the behavior of the surrounding nebula and the binary system as it undergoes its final stages, astronomers could gather invaluable data on the processes that govern black hole formation. As the study of Eta Carinae progresses, we will undoubtedly uncover more secrets about this fascinating star system. The advancements in telescopic technology, including infrared and X-ray observations, will continue to offer new insights into the star's structure and behavior. Furthermore, theoretical models of stellar evolution and black hole formation will continue to evolve as our understanding of these extreme environments deepens. What's clear, however, is that Eta Carinae is one of the most enigmatic and important objects in our galaxy, a beacon of mystery and wonder that will continue to inspire scientific inquiry for generations to come. The story of Eta Carinae is a story of cosmic resilience. Despite the many ways in which it defies expectations and challenges our understanding of stellar evolution, this star has continued to thrive in ways that few thought possible. Its eruptions, its binary companion, and its eventual fate all remind us that the universe is filled with surprises, and that even the most well-understood scientific principles can be challenged by the raw power of nature. Eta Carinae is not just a star, it is a symbol of the unknown, a testament to the vast, uncharted realms of space that still remain beyond our grasp. As we continue to unravel the mysteries of Eta Carinae, it's crucial to place this star in the larger context of stellar evolution and galactic dynamics. Eta Carinae is an extraordinary example of the extremes in the life cycle of massive stars, and its study offers a window into understanding the fate of other massive stars in our galaxy. But what makes it even more intriguing is the question of why it has defied the typical pattern of stellar life and death. While most massive stars follow a relatively predictable path toward their eventual demise, first exhausting their hydrogen fuel, then transitioning through phases like the red supergiant phase, and ultimately collapsing into a supernova, Eta Carinae's erratic behavior suggests that there may be a more complex set of processes at play. This non-traditional path challenges everything we thought we knew about stellar evolution. Astronomers have been trying to piece together the reasons behind its unpredictability for decades. While the physical mechanisms behind its eruptions remain a topic of active research, there are some leading theories that attempt to explain this star's behavior. One prominent theory involves the presence of large-scale magnetic fields within the star. Magnetic fields can act as conduits for energy and matter, sometimes causing bursts of material to be ejected from a star in unexpected ways. These magnetic fields might be responsible for the irregular outbursts observed in Eta Carinae. Such outbursts could be the result of a complex interaction between the magnetic fields and the intense pressure within the star's core, triggering eruptions of matter as the star attempts to relieve internal stresses. This would also explain the periodic nature of the outbursts, as magnetic field configurations could shift over time, causing cycles of increased instability. Additionally, the binary nature of the system is likely a contributing factor to the star's erratic behavior. Binary star systems, where two stars are gravitationally bound to each other, can lead to a wide range of phenomena, such as mass transfer between the stars or gravitational interactions that can trigger the shedding of material. The companion star in the Eta Carinae system could be playing a critical role in the star's outbursts. When the stars pass close to each other in their eccentric orbit, the gravitational tug-of-war between them could lead to the transfer of material from one star to the other, causing increased instability and resulting in massive outflows of gas and dust. These interactions could also explain why Eta Carinae appears to experience bursts of energy and mass loss, unlike other massive stars that steadily burn through their fuel until their eventual death. Furthermore, the Carinae Nebula itself offers important clues about the broader processes that are shaping Eta Carinae. The nebula is one of the most active regions in the Milky Way, filled with hot young stars, and is known for its rich mix of gas, dust, and cosmic rays. The constant interplay of material within the nebula could be feeding into the cycles of instability within Eta Carinae, influencing its behavior in ways that are not yet fully understood. This active environment suggests that Eta Carinae's interactions with its surroundings are contributing to its unusual eruptions and unpredictable behavior, potentially shaping the future of the entire nebula and its star-forming activity. Interestingly, observations of Eta Carinae have revealed that the star system has already undergone several dramatic outbursts, with the Great Eruption being the most notable. But the story doesn't end there. As the star continues to evolve, more dramatic outbursts may still lie ahead, each one shedding more of its mass and further altering its future trajectory. The precise timing of these events, however, remains unclear, as it is difficult to predict the behavior of such an unstable star. What we do know is that each of these outbursts contributes to the ongoing transformation of Eta Carinae, ultimately leading to its eventual fate. For all the mystery surrounding its future, one thing is certain: Eta Carinae's fate will have profound implications not just for the star itself, but for the surrounding nebula, and potentially even the wider galaxy. The energy released by the star's eventual explosion, whether in a supernova, a gamma-ray burst, or some other dramatic event, will reverberate throughout the region, influencing the formation of new stars, the development of planetary systems, and the evolution of the surrounding interstellar medium. This feedback loop, where a single massive star's death can lead to the birth of new stellar objects, is an essential part of the cycle of cosmic creation and destruction that governs the universe. In the context of galactic evolution, Eta Carinae's behavior is not unique. While it is one of the most extreme examples of stellar instability, other massive stars in different regions of the galaxy likely experience similar phases of mass loss, outbursts, and eventual death. The study of Eta Carinae provides valuable insights into the complex dynamics of star formation, evolution, and death. By examining how Eta Carinae interacts with the Carinae Nebula, how its binary system influences its evolution, and how its periodic eruptions contribute to the surrounding environment, astronomers can better understand the fate of other massive stars in the galaxy. In a way, Eta Carinae acts as a prototype for the many massive stars scattered throughout the universe, allowing scientists to make predictions about the future of other similar systems. Despite all the progress in our understanding, Eta Carinae continues to be a source of intrigue and fascination. It is a reminder of how much we still have to learn about the universe and how many mysteries remain unsolved. As our technological capabilities advance, with the development of next-generation telescopes and improved observational techniques, we may be able to observe more about the dynamics of Eta Carinae and its environment. Perhaps we will witness more dramatic outbursts from this enigmatic star, each one providing new data to further refine our models of stellar evolution. Or perhaps, as the star nears the end of its life, we will observe a breathtaking and unprecedented event that changes our understanding of the very nature of the cosmos. Ultimately, the story of Eta Carinae serves as a testament to the power and mystery of the universe. It is a reminder that, despite the vast amount of knowledge we have gained about the cosmos, there are still countless phenomena that defy explanation. Eta Carinae, with its violent eruptions, its unstable nature, and its mysterious future, represents the unpredictable and awe-inspiring forces at work in the universe. Whether it ends in a supernova, collapses into a black hole, or takes some other path, Eta Carinae will continue to be one of the most captivating objects in the sky, a star that refuses to die, defying the laws of stellar evolution and continuing to surprise us with its unpredictable and fascinating behavior. As we venture deeper into the mysteries surrounding Eta Carinae, it's important to consider not just its current state, but its legacy in the greater cosmic context. The study of stars like Eta Carinae, which defy our expectations and challenge our understanding of stellar evolution, has profound implications for our view of the universe. These types of stars are cosmic laboratories where we can test the limits of physics and expand our understanding of how stars evolve, die, and influence their surrounding environments. One of the most fascinating aspects of Eta Carinae's evolution is its potential to reshape our models of stellar death. Typically, massive stars undergo a relatively predictable process toward their end, culminating in an explosion, either a supernova or some other cataclysmic event. However, Eta Carinae has resisted this path, experiencing dramatic outbursts and mass loss long before the traditional supernova stage. This complicates the narrative of stellar evolution and forces astronomers to consider new mechanisms and phenomena that could govern the behavior of these massive stars. The star's future remains a tantalizing mystery. If Eta Carinae continues to shed mass in these spectacular bursts, the loss of material could slow its ultimate collapse into a supernova or black hole. Alternatively, if the star's outbursts suddenly cease or intensify, it could lead to a more rapid and dramatic end. What's clear, however, is that Eta Carinae's ultimate fate will likely have an incredible impact on the surrounding region of space, contributing to the next generation of stars and possibly influencing the formation of new planetary systems. One theory that has emerged to explain the star's unpredictable nature is that it may be undergoing an internal process known as stellar pulsation. In certain stars, the internal pressure and energy release fluctuate in such a way that the star periodically expands and contracts. This pulsation could explain the erratic mass loss observed in Eta Carinae, where its outer layers are periodically expelled into space. Pulsations are common in stars that are nearing the end of their lives, and if Eta Carinae is indeed pulsating, it could represent a unique stage in its evolution, one that deviates from the standard trajectory expected of other massive stars. As researchers continue to probe Eta Carinae with increasingly sophisticated instruments, the star offers invaluable insights into the behavior of stars in extreme environments. It is possible that the same processes occurring in Eta Carinae may also be at play in other stars that are undergoing similar periods of instability. By comparing the outbursts of Eta Carinae to those of other massive stars in various stages of evolution, astronomers hope to unravel the deeper patterns behind these unusual stellar behaviors and gain insight into the nature of stellar evolution itself. At the same time, the star's dramatic eruptions provide a unique opportunity to study the behavior of matter under extreme conditions. The outflows of gas and dust from Eta Carinae are not only fascinating for their own sake but also serve as a laboratory for testing theories of high-energy astrophysics. The extreme temperatures, pressures, and magnetic fields associated with the star's outbursts create an environment unlike anything we can replicate on Earth. Understanding how matter behaves in such extreme conditions could lead to breakthroughs in our understanding of fundamental physics, from the properties of exotic matter to the behavior of magnetic fields and radiation in astrophysical systems. Furthermore, the discovery of new, more powerful telescopes and observational technologies has opened the door to unprecedented opportunities to monitor Eta Carinae in real time. Instruments like the James Webb Space Telescope, JWST, and the upcoming Extremely Large Telescope, ELT, offer new ways to peer deeper into the star system than ever before. With these advancements, astronomers will be able to observe the star in greater detail, potentially capturing the next dramatic outburst or observing the star as it undergoes a crucial phase in its evolution. These observations will undoubtedly shed new light on the star's behavior and give us a more complete picture of its cosmic journey. But even beyond the scientific value, there is something deeply poetic about the life of Eta Carinae. This star, in all its violent grandeur, serves as a powerful reminder of the impermanence and chaos that characterizes the universe. It is a symbol of the forces at play in the cosmos, forces that are often beyond our comprehension, yet endlessly fascinating. Stars like Eta Carinae remind us that the universe is alive with activity, constantly in motion, evolving, and changing in ways we can only begin to understand. In a larger sense, the study of such objects invites us to reflect on our place in the universe. We live on a tiny blue planet in a vast cosmos, and while we may feel insignificant in the grand scale of things, the study of stars like Eta Carinae shows that we are part of something much greater. Each outburst from this star is a cosmic event, a glimpse into the very mechanisms that govern the birth and death of stars. Our ability to observe and understand these processes connects us to the very fabric of the universe, allowing us to gain a deeper appreciation for the cosmic forces that shape everything around us. Moreover, the mysteries of Eta Carinae are not just academic, they capture the imagination of the public and inspire curiosity about the universe. Every time a new discovery is made about this enigmatic star, it sparks a wave of excitement, as people wonder what this star might reveal next. Eta Carinae, in all its unpredictability, reminds us that there is still so much about the universe we have yet to uncover. It is a star that refuses to die, and in doing so, it challenges our assumptions and keeps us coming back to explore its secrets. Ultimately, the tale of Eta Carinae is far from over. As we continue to gather data and observe its behavior, we may one day witness the final act in the life of this extraordinary star. Whether it will end in a spectacular supernova, collapse into a black hole, or take some other unexpected form, one thing is certain: the story of Eta Carinae is one that will continue to captivate the imagination of astronomers and stargazers alike for generations to come. The great eruption of Eta Carinae has shown us that the universe is not a predictable place. It's filled with extraordinary phenomena that defy logic, burst through the bounds of scientific understanding, and present us with questions that have no immediate answers. Yet, in this uncertainty, there is also beauty. There is awe. And there is the promise that as long as we continue to ask questions and push the limits of our knowledge, we will keep uncovering the mysteries of the cosmos, one unpredictable eruption at a time. The tale of Eta Carinae's explosive nature continues to challenge our understanding of stellar life cycles and fuels debates among astronomers. Despite centuries of observation and research, this mysterious star remains an enigma, with its behavior raising more questions than answers. This is part of what makes Eta Carinae such a fascinating subject of study. Not only does it defy our expectations about what we thought we knew about massive stars, but it also reveals that our models of stellar evolution are incomplete. At its core, Eta Carinae is not just a single star, but a binary system. This fact complicates the narrative surrounding the star even further. The system consists of two massive stars orbiting one another, with one of these stars being particularly massive, estimated to be about 100 times the mass of our Sun. The other star, while still massive by stellar standards, is significantly smaller, weighing in at around 30 solar masses. The interaction between these two stars is thought to play a major role in the dramatic outbursts we see from the system. The massive star, which is the primary contributor to the dramatic outbursts of Eta Carinae, is a so-called Wolf-Rayet star, a highly evolved type of star that has lost much of its outer layers due to intense stellar winds. Wolf-Rayet stars are known for their violent mass loss, and this characteristic makes them unstable in their later stages of life. Eta Carinae's primary star is thought to have gone through several phases of mass loss, shedding substantial portions of its outer envelope over the centuries. The smaller companion star, meanwhile, is also playing an important role in the system's dynamics. It orbits the massive star at a relatively short distance, which means that the gravitational forces between the two stars are extraordinarily strong. These forces likely cause periodic interactions, such as the transfer of mass from one star to another, which could explain some of the extreme outbursts that have been observed. Interestingly, the massive star's powerful outbursts may also be linked to the intense radiation environment generated by the binary system. As the stars orbit each other, they emit vast amounts of radiation, which can ionize the surrounding gas and create powerful shockwaves. These shockwaves, in turn, might contribute to the incredible energy released during the star's periodic eruptions. The combination of these forces, stellar winds, radiation pressure, and gravitational interactions, creates a volatile and ever-changing environment, one that is both difficult to model and impossible to fully predict. As the two stars in the Eta Carinae system orbit each other, they are also slowly moving through space, and this motion has implications for their future. While we may not be able to fully predict when the next massive eruption will occur, it is possible that the two stars will eventually merge. If this happens, the resulting explosion could rival some of the most powerful supernovae ever observed. The idea of a stellar merger is not new to the field of astronomy, but the specific conditions in which Eta Carinae exists make it an especially intriguing possibility. A merger between these two stars would not only release an enormous amount of energy but could also mark the final chapter in the life of the system. Beyond the binary system's interactions, Eta Carinae's enormous mass loss has had significant consequences for its surroundings. The massive outbursts from the star system have expelled vast amounts of gas and dust into space, creating a nebula that is both beautiful and full of mysteries. This nebula, known as the Homunculus Nebula, is a key feature of the Eta Carinae system and has been the subject of much study. The nebula's intricate structure is the result of the massive amounts of material ejected by the star during its earlier eruptions. The Homunculus Nebula is not just a testament to Eta Carinae's destructive power, but also a fascinating example of stellar death. It is likely that the material in the nebula will eventually be incorporated into the next generation of stars and planets. In a way, the death of Eta Carinae will provide the raw materials for the creation of new cosmic objects, continuing the cycle of stellar birth and death that defines the universe. While the Homunculus Nebula is an awe-inspiring sight, it also serves as a reminder of the violent nature of stellar evolution. Eta Carinae is in the process of shedding its outer layers, and the nebula is the evidence of this ongoing transformation. It is thought that the nebula will continue to expand and evolve over time, providing a unique opportunity for astronomers to study the life cycle of stars in real time. However, Eta Carinae's journey is far from over, and there are still many unknowns about how this star system will end. Some astronomers believe that Eta Carinae could eventually go through a dramatic event known as a core collapse supernova. This is a process where a massive star's core collapses under the force of gravity, leading to an explosion that can outshine an entire galaxy. Such an event would release a tremendous amount of energy, and if it occurs in Eta Carinae's future, it could be visible to astronomers from Earth even without the aid of telescopes. While a supernova would be an extraordinary event, it is not the only possibility. Given Eta Carinae's unstable and unpredictable nature, there is a chance that the star could collapse directly into a black hole without going through the typical supernova explosion. This is another area of active research, as black holes are some of the most mysterious and elusive objects in the universe. If Eta Carinae were to collapse into a black hole, it would leave behind a powerful remnant, one that could influence the surrounding space for millions of years. Regardless of how the star ultimately meets its end, the fact that Eta Carinae continues to confound scientists makes it an invaluable object of study. The more we learn about Eta Carinae, the more we realize just how little we truly understand about the cosmos. In many ways, the star's unpredictability mirrors the inherent uncertainty of the universe itself. For every discovery we make, we uncover more questions, and Eta Carinae, in all its explosive glory, embodies this ongoing quest for knowledge. Through its powerful outbursts, its enigmatic behavior, and its ultimate fate, Eta Carinae will undoubtedly continue to captivate astronomers and stargazers alike. The star has already taught us so much about the forces that shape the cosmos, and its story is far from finished. As new technologies and techniques emerge, we may one day witness the final act of this extraordinary stellar drama, and when that moment comes, it will be a testament to the enduring mystery and beauty of the universe. As we venture deeper into the phenomena surrounding Eta Carinae, the complexity of its behavior continues to perplex and inspire those who study it. While the star has been the subject of intense scrutiny for centuries, we are only now beginning to scratch the surface of understanding just how much influence it has had on the surrounding cosmos, and how it fits into the grander narrative of stellar evolution. One aspect of Eta Carinae's uniqueness is its role in the broader cosmic ecosystem. The massive outbursts, the expulsion of material, and the radiation generated by this star system have repercussions that extend far beyond its immediate vicinity. These violent eruptions and high-energy emissions interact with the surrounding gas and dust, triggering processes that could eventually lead to the formation of new stars and planetary systems. In essence, Eta Carinae is not just a dying star but a cosmic factory, churning out the materials necessary for the birth of future stars and the evolution of interstellar matter. This dynamic process is what makes massive stars like Eta Carinae so crucial in the context of the universe's ongoing life cycle. While smaller stars like our Sun eventually reach the end of their lives and transition into white dwarfs, massive stars go out in a blaze of glory, their death giving birth to the very elements that will shape the next generation of stars. In this sense, Eta Carinae serves as both an end and a beginning. Its violent death will give rise to new stars, nebulae, and potentially even planets. The study of Eta Carinae is also a study of the extremes of stellar behavior. This star system provides astronomers with a rare opportunity to observe a star on the verge of a cataclysmic end, and the data gathered from this system helps to inform our understanding of the upper limits of stellar mass, evolution, and death. There is a particular fascination with the possibility that Eta Carinae could be a progenitor of a black hole, adding another layer of intrigue to its already complex narrative. While black holes are traditionally seen as mysterious and distant objects, the potential for one to form in our cosmic backyard is both fascinating and unsettling. In fact, the process of a star collapsing into a black hole is one of the most mysterious and poorly understood phenomena in astrophysics. It is thought that when a massive star exhausts its fuel, the core collapses under the force of gravity, eventually forming a singularity, a point in space where gravity is so intense that nothing, not even light, can escape. This event is often accompanied by a gamma-ray burst, one of the most energetic events in the universe. Theoretically, Eta Carinae could undergo a similar process, though the specifics of how it might unfold are still unclear. The unique characteristics of the star system, including the presence of its companion star, suggest that the path toward a black hole could take an unexpected route, with a merger of the two stars potentially triggering a dramatic end. If Eta Carinae does indeed collapse into a black hole, the event would represent a profound shift in our understanding of the universe. It would challenge our ideas of what it means for a star to die, as the transition from a star to a black hole is not only dramatic but also somewhat elusive. The vast majority of black holes we observe are formed from the remnants of stars much smaller than Eta Carinae, so the possibility that this system could create a black hole of such massive proportions has profound implications for our understanding of stellar evolution, gravity, and the nature of singularities. Another crucial aspect of the Eta Carinae system is its peculiar behavior in terms of light and radiation. When astronomers observe stars, they generally expect a consistent pattern of light emissions, at least within the same stage of a star's life. However, Eta Carinae is anything but predictable. Its outbursts, which have occurred periodically throughout history, defy the conventional rules of stellar observation. This is partly due to the interaction between the two stars in the binary system, which causes significant fluctuations in the amount of light emitted by the system. As the stars orbit one another, their gravitational pull on each other causes irregular changes in their luminosity, leading to the erratic fluctuations observed. These fluctuations make it difficult for astronomers to predict when the next outburst will occur, adding an element of unpredictability to the already mysterious nature of the star. The irregularity of the eruptions and the scale of the energy released make Eta Carinae an exceptional target for study. While we have a general understanding of the processes at play in the system, the full details of the interactions between the two stars are still a matter of ongoing investigation. The star's unpredictable behavior is not just fascinating but also offers a glimpse into the chaotic nature of the universe itself. In many ways, the story of Eta Carinae is a microcosm of the broader mysteries of space. Despite our advancements in technology and understanding, there are still many things that elude our grasp. The study of Eta Carinae challenges our assumptions about stellar evolution and pushes the boundaries of what we thought was possible in terms of stellar life cycles. As we continue to observe this enigmatic system, we are reminded of the inherent uncertainty of the cosmos and the vastness of what we have yet to explore. While Eta Carinae may not be the only massive star undergoing a violent death, it is certainly one of the most studied, and its behavior has far-reaching implications for our understanding of the universe. Its mysterious eruptions, unpredictable behavior, and potential to collapse into a black hole make it a focal point for astronomers seeking to unravel the secrets of the cosmos. The more we learn about this star, the more we realize how much there is still to discover. As new technologies allow us to observe the universe in greater detail, our understanding of stars like Eta Carinae will only deepen. In the future, we may be able to observe even more of the star's final stages, and this could provide invaluable insights into the end stages of massive stars, their role in the formation of black holes, and the dynamics of binary star systems. Eta Carinae's story is far from over, and it will undoubtedly continue to captivate astronomers and stargazers alike. As we continue to peer into the depths of space, we are reminded that even the most well-understood phenomena often contain mysteries that are yet to be unraveled. The story of this star, like so many others, is one of constant discovery, an ongoing journey into the unknown, where every new revelation only leads to more questions and a deeper appreciation for the complexity and beauty of the universe. And so, Eta Carinae remains a beacon in the sky, not just for the light it emits but for the mysteries it holds. As we watch it from our vantage point on Earth, we are reminded of the boundless curiosity that drives our quest for knowledge. The eruption of Eta Carinae may one day be a defining moment in the study of the cosmos, and its legacy will continue to inspire generations of astronomers, scientists, and dreamers. What we learn from this extraordinary star system will shape our understanding of the universe for years to come, and its story is far from finished. As we continue to observe Eta Carinae, we must consider the broader context in which this star operates. Eta Carinae's extreme behavior provides a window into the most violent and energetic processes in the universe. While stars like the Sun follow a more predictable and tranquil path through their life cycle, massive stars like Eta Carinae exist in a realm of extremes that challenge our understanding of physics, astrophysics, and the life cycles of stars. The outbursts, the shedding of mass, and the ever-changing dynamics between the two stars in this system are an extraordinary showcase of the universe's untamed potential. The implications of Eta Carinae's massive eruptions extend beyond just the star itself. The material it expels into the surrounding space enriches the interstellar medium, contributing to the cosmic recycling process that is fundamental to the formation of new stars, planets, and potentially even life. This is a reminder that stars are not just passive objects in space. They are active participants in the ongoing cycle of creation and destruction that shapes the universe. When Eta Carinae sheds its outer layers in these violent outbursts, it is providing the very building blocks for future generations of stars. The study of this star also reveals the incredible complexity of binary star systems. While single stars, such as our Sun, follow a more straightforward path, binary stars often experience gravitational interactions that create unstable environments. In the case of Eta Carinae, the gravitational tug-of-war between the two stars results in dramatic variations in luminosity, stellar activity, and even the outbursts we see. This complexity is not just fascinating in its own right but also serves as a model for studying other binary systems, many of which may harbor similar violent tendencies. Astronomers have also found that the two stars in Eta Carinae, despite their extraordinary masses and extreme behavior, are not unique in their interactions. Binary star systems are thought to be relatively common in the universe, and some of them could be undergoing similar processes. While none may be as extreme as Eta Carinae, the study of this system provides important clues about the behavior of other massive binary stars. The chaotic interaction between the two stars in Eta Carinae could provide insights into the larger-scale processes that govern the evolution of massive stars, helping us to understand how the most energetic stars in the universe behave. The mystery of the Great Eruption continues to draw the attention of astronomers and astrophysicists, as it is not only one of the largest outbursts ever recorded from a star, but also one of the most difficult to explain. While we know that Eta Carinae is undergoing periodic outbursts, the reasons for the timing and intensity of these eruptions remain unclear. Some researchers suggest that the outbursts could be linked to the gravitational interactions between the two stars, which might periodically cause material to be ejected from the system. Others propose that the eruptions are the result of internal instability within one or both of the stars, with mass loss occurring in bursts due to fluctuations in the star's internal pressure. One of the most compelling aspects of Eta Carinae's behavior is how it forces us to rethink the processes that govern the evolution of massive stars. Traditionally, we have assumed that massive stars have a fairly predictable life cycle, following a well-established sequence of nuclear fusion, mass loss, and eventual collapse into a supernova or black hole. However, the erratic behavior of Eta Carinae suggests that this model may be too simplistic, and that stars like Eta Carinae could exhibit far more complex and unpredictable patterns. This unpredictability challenges our understanding of stellar evolution and raises questions about the limits of our current models. Can we truly predict how stars will behave in the final stages of their lives? How much variability is there in the processes that govern star formation, evolution, and death? The continued study of Eta Carinae offers an opportunity to answer these questions, providing astronomers with a natural laboratory to explore the limits of stellar physics. Another aspect of Eta Carinae's mystery is its potential to unlock the secrets of supernovae and black hole formation. We know that when massive stars reach the end of their lives, they can collapse under the force of gravity, resulting in a supernova or, in the most extreme cases, the formation of a black hole. But the path that a star like Eta Carinae will take to reach this end is still unclear. Could its massive eruptions be a precursor to a final, cataclysmic event? Could Eta Carinae evolve into a supernova or collapse directly into a black hole, bypassing the supernova stage altogether? These questions are particularly important because Eta Carinae is one of the most massive star systems that we can observe in detail. Studying its behavior can help us refine our models of stellar death, shedding light on the different ways that massive stars can meet their end. The fact that Eta Carinae has already experienced a massive outburst, followed by a period of relative quiet, only adds to the intrigue surrounding its eventual fate. Will the star undergo another dramatic outburst, or will it slowly transition into its final form? The answers to these questions will have profound implications for our understanding of the life cycles of massive stars. As astronomers continue to monitor Eta Carinae, they are also working to develop new technologies and techniques to study it in even greater detail. The Hubble Space Telescope, which has been instrumental in observing Eta Carinae, continues to provide valuable data, but future missions and observatories could offer even more powerful tools for understanding this enigmatic system. The James Webb Space Telescope, for example, is expected to offer a new level of detail in infrared observations, which could provide a clearer picture of the inner workings of Eta Carinae and its companion star. With the advent of these new technologies, the mysteries surrounding Eta Carinae are sure to deepen, and our understanding of the star will continue to evolve. Eta Carinae is not just an object of scientific curiosity, it is a symbol of the unknown. It reminds us that the universe is full of surprises, and that even the most well-studied phenomena can still hold secrets. Its violent eruptions, its potential to collapse into a black hole, and its role in the creation of new stars all make it one of the most fascinating objects in the universe. As we continue to study Eta Carinae, we are not only learning about this star system but also gaining insights into the larger processes that shape the universe. The more we learn about Eta Carinae, the more we realize how little we truly know about the cosmos. It serves as a reminder that space is an endless frontier, filled with wonders that we have yet to comprehend. As we peer deeper into the universe, stars like Eta Carinae continue to challenge our understanding and expand our knowledge. The mysteries of the universe are far from solved, and with each new discovery, we take another step closer to understanding the vast, complex, and awe-inspiring cosmos that we call home. As we continue to unravel the mystery of Eta Carinae, we must also consider the broader implications of its behavior for our understanding of the universe. While the star's outbursts and extreme features are fascinating in their own right, they also offer critical insights into the dynamics of massive stars, their life cycles, and the larger cosmic forces at play. Eta Carinae is not just an isolated phenomenon, it serves as a window into the forces that shape the universe on the grandest scales. One of the most intriguing aspects of Eta Carinae is the way it challenges our understanding of star formation and evolution. Traditionally, astronomers have relied on models of stellar evolution that focus on single stars and their predictable life cycles. However, Eta Carinae, with its massive size and unpredictable eruptions, reveals that binary star systems can behave in entirely different ways. These systems, where two stars interact gravitationally, can exhibit far more complex behavior than their single-star counterparts. The eruption of Eta Carinae, and its potential to evolve into a supernova or black hole, highlights the unique challenges that come with studying such systems. In fact, the study of Eta Carinae has helped astronomers reconsider the very nature of massive stars. While most stars, like our Sun, follow a relatively stable path through their lifetimes, massive stars like Eta Carinae are prone to sudden outbursts and mass loss. This can make their life cycles far more chaotic and difficult to predict. Understanding how these massive stars evolve, and how their behavior influences the formation of new stars, can provide key insights into the processes that govern the birth and death of stars in the universe. Additionally, the two stars in the Eta Carinae system interact in ways that are unlike those of most binary systems. The gravitational influence between the two stars creates an environment where one star can siphon off material from the other, leading to massive outbursts like the Great Eruption. This dynamic relationship is central to understanding the future of the system and its eventual fate. As the stars continue to interact and evolve, they may reach a point where one or both will eventually collapse into a black hole. This possibility adds another layer of intrigue to the story of Eta Carinae, as it suggests that the star system may undergo dramatic transformations in the future. The implications of Eta Carinae's eventual collapse are profound. If the star system were to end in a supernova, it would release an enormous amount of energy and matter into space, enriching the surrounding interstellar medium with heavy elements. This process, known as nucleosynthesis, is responsible for the creation of the elements that make up the universe, from carbon and oxygen to iron and gold. The death of a massive star like Eta Carinae would be a spectacular event, sending shockwaves through the surrounding space and potentially triggering the formation of new stars and planetary systems. However, the possibility that Eta Carinae could collapse directly into a black hole, bypassing the supernova phase, would be just as significant. Black holes are some of the most mysterious and enigmatic objects in the universe, and understanding how they form is key to understanding the nature of gravity, space-time, and the fundamental laws of physics. If Eta Carinae were to collapse into a black hole, it would provide a unique opportunity to study the conditions under which black holes form and evolve. This could lead to new insights into the behavior of matter and energy near the event horizon, as well as the processes that govern the life cycles of the most massive objects in the universe. One of the most exciting aspects of studying Eta Carinae is the potential for future discoveries. With advancements in technology and observational techniques, astronomers are now able to study distant stars and star systems in more detail than ever before. The upcoming James Webb Space Telescope, JWST, for example, promises to offer unprecedented infrared observations of distant objects like Eta Carinae, allowing scientists to peer deeper into the star's interior and better understand its behavior. The JWST, with its advanced optics and ability to observe in the infrared spectrum, could provide a level of detail that was previously unimaginable, allowing astronomers to study the star's composition, temperature, and other key characteristics in new ways. Beyond the JWST, there are also a number of other upcoming space missions and observatories that could provide valuable data on Eta Carinae. For example, the European Space Agency's ESA Gaia mission, which is designed to map the positions and motions of stars with unprecedented precision, could offer new insights into the behavior of the stars in the Eta Carinae system. By studying the orbits and interactions of these stars in greater detail, astronomers could gain a deeper understanding of the forces that govern their behavior and how they are evolving over time. As our understanding of Eta Carinae grows, so too does our understanding of the larger processes that govern the universe. The star's violent outbursts and potential to collapse into a black hole remind us that the cosmos is a dynamic and ever-changing place. Stars like Eta Carinae are not static objects. They are constantly evolving, shedding mass, and interacting with their surroundings in ways that shape the fabric of space itself. These stars are the engines of the universe, driving the processes that create new elements, new stars, and even new galaxies. The great eruption of Eta Carinae, in particular, serves as a reminder of the raw power that stars can unleash. While most stars burn quietly for billions of years, massive stars like Eta Carinae burn with an intensity that is almost unimaginable. Their eruptions, while destructive, also contribute to the ongoing cycle of creation and destruction in the universe. Each eruption is a moment of cosmic rebirth, where the material expelled from the star is recycled into the interstellar medium, providing the building blocks for future generations of stars and planets. The ongoing study of Eta Carinae will undoubtedly continue to yield new discoveries, as astronomers use the latest technologies to probe the star's secrets. As we learn more about this enigmatic system, we will continue to expand our understanding of the most extreme environments in the universe. From the forces that govern the interactions of massive stars to the processes that drive their evolution, the study of Eta Carinae promises to unlock some of the most profound mysteries of the cosmos. Eta Carinae is a reminder of the vastness and complexity of the universe. It is a star that refuses to die, continually surprising us with its unpredictable behavior and offering clues into the forces that govern the cosmos. As we look to the future and continue to study Eta Carinae and other massive stars like it, we are reminded that the universe is full of mysteries waiting to be unraveled. The journey of discovery is ongoing, and with each new observation, we take another step closer to understanding the cosmos in all its awe-inspiring complexity. As we move further into the fascinating mystery of Eta Carinae, we cannot help but marvel at the intricacies of stellar behavior that this star showcases. While we've explored its incredible outbursts, mass loss, and binary dynamics, there are still a number of unresolved questions that continue to challenge astronomers. These questions open up new realms of investigation not only about Eta Carinae itself but also about how stars in general evolve, interact, and die. The answers we uncover will have profound implications for our understanding of star systems, galactic evolution, and the fundamental forces shaping the universe. One of the biggest unanswered questions regarding Eta Carinae's future is whether it will continue to experience additional outbursts, or if its behavior will eventually stabilize. Some astronomers believe that the Great Eruption might represent a one-time event in the star's life cycle, a violent episode of instability caused by a unique confluence of circumstances in its evolutionary history. Others argue that these outbursts might be cyclical, occurring at irregular intervals over the course of the star's lifetime, each one pushing it closer to its eventual demise. The fact that we are still uncertain about the frequency and nature of these outbursts makes Eta Carinae a particularly fascinating object of study. Further complicating matters is the issue of mass loss. The intense radiation and stellar wind produced by massive stars like Eta Carinae carry away vast amounts of material into space. This mass loss is one of the key factors that determines the star's future evolution. As the star sheds mass over time, it may become less capable of supporting the internal pressures necessary to sustain nuclear fusion. When this happens, the star will ultimately collapse, triggering a supernova explosion, or possibly even a collapse directly into a black hole. The amount of mass lost during Eta Carinae's outbursts, combined with its current state, could determine whether it undergoes a supernova or follows a different, more extreme path. The unpredictability of the star's mass loss and its relationship with the surrounding interstellar medium only heighten the mystery of its eventual fate. Another intriguing aspect of Eta Carinae's history and behavior is the question of how common it is for stars to exhibit such unpredictable and violent behavior. While we are fortunate to have such a remarkable and relatively close example in Eta Carinae, it is still unclear how widespread such phenomena are in the universe. Eta Carinae's large mass, coupled with its binary nature, makes it an ideal candidate for such dramatic outbursts, but astronomers are still working to determine whether these types of events are rare or more common than we realize. Some researchers believe that other massive binary star systems, especially those hidden from our view by dense interstellar dust or located in distant galaxies, may be undergoing similar outbursts without our knowledge. As our ability to observe more distant and faint stars improves, it is possible that we will discover many other stars that exhibit similar behaviors to Eta Carinae, each contributing to our understanding of the wide range of star evolution. The discovery of these hidden systems could have profound implications for our understanding of stellar evolution and the role of binary interactions in the development of massive stars. While most stars evolve in relative isolation, the intense gravitational pull between two stars in a binary system creates conditions that can lead to dramatic changes in their behavior. These systems may go through rapid phases of instability, such as outbursts, before eventually stabilizing or collapsing into black holes. Understanding these complex dynamics could not only answer questions about individual stars like Eta Carinae but also provide insight into the larger processes that govern star formation, interaction, and death. In addition to the immediate mystery surrounding Eta Carinae's evolution, its behavior could also help inform our understanding of cosmic events that have larger-scale consequences. The violent outbursts of massive stars play a crucial role in enriching the interstellar medium with heavier elements. When a star undergoes a supernova or black hole formation, it ejects vast amounts of material, some of which becomes part of the cosmic dust that eventually coalesces to form new stars, planets, and even life. In this sense, Eta Carinae's ultimate fate could contribute to the formation of future generations of stars and planets, potentially influencing the development of entire star clusters or even entire galaxies. The interstellar dust and material released by massive stars like Eta Carinae can also help answer questions about the origin of life. The heavy elements produced in stellar explosions, such as carbon, nitrogen, and oxygen, are the very building blocks of life as we know it. Understanding how and when these elements are released into space is crucial for understanding the potential for life beyond our solar system. Could the remnants of Eta Carinae's eventual explosion seed new worlds with the necessary components for life? It's a tantalizing possibility, one that underscores the interconnectedness of cosmic processes. Even as we look to the future of Eta Carinae's life cycle, it is important to recognize the role that technological advancements will continue to play in our ability to study this extraordinary star. Over the past few decades, we've made tremendous strides in the field of observational astronomy, with new space telescopes, ground-based observatories, and cutting-edge instruments pushing the boundaries of our understanding. Eta Carinae is a prime target for the next generation of astronomical research, as scientists seek to collect as much data as possible before the star reaches its ultimate fate. As we continue to explore the cosmos, it is likely that we will uncover new phenomena and mysteries that further challenge our understanding of how stars like Eta Carinae live, die, and contribute to the larger processes that shape the universe. With each new observation, we come closer to understanding the nature of massive stars, the dynamics of binary systems, and the complex processes that drive stellar evolution. But Eta Carinae is more than just an object of scientific curiosity. It is a testament to the awe-inspiring forces at work in the universe. The star's power, unpredictability, and potential for dramatic change serve as a reminder of the vastness of the cosmos and the incredible mysteries that lie just beyond our reach. As astronomers continue to probe its secrets, we can only imagine the new revelations that await. In the grand scheme of things, the story of Eta Carinae is far from over. Its future, though uncertain, holds the potential for both spectacular discoveries and profound revelations about the universe. Whether it collapses into a black hole or explodes in a supernova, Eta Carinae's journey is a reminder of the dynamic nature of the cosmos and the ever-present forces of creation and destruction that shape it. By studying this extraordinary star, we gain not only insights into the life cycle of massive stars but also a deeper understanding of the complex, interconnected nature of the universe itself. The ultimate fate of Eta Carinae may still be unknown, but one thing is certain: it will continue to captivate our imaginations and challenge our understanding of the cosmos for generations to come. As we continue to delve deeper into the mysteries surrounding Eta Carinae, one of the most fascinating aspects of the star system is the role it plays in influencing its surrounding environment. The sheer size and energy emitted by Eta Carinae are not only influencing its immediate surroundings but also contributing to the larger-scale dynamics of the interstellar medium. The wind of particles ejected by the star, as well as the intense radiation emitted from both the primary and secondary stars, affect the surrounding gas and dust, sculpting the region around them in ways that are still being studied by astronomers. The wind emanating from the massive stars of Eta Carinae is particularly noteworthy due to its incredible strength. These stellar winds are composed of charged particles, primarily protons and electrons, which are blasted away from the stars at incredible speeds, often approaching 10,000 kilometers per second. Such winds are not unique to Eta Carinae, as massive stars across the universe generate powerful stellar winds. However, the specific conditions within this star system, its unusual binary nature, the high luminosity of both stars, and their proximity to one another, make the winds in this system particularly extreme. These stellar winds play a key role in shaping the surrounding nebula, which is made up of gas and dust particles, some of which are left over from previous eruptions and stellar winds, while others are remnants of the star's earlier formation. The interaction between the intense radiation from the stars and the surrounding nebula causes the gas to glow, creating the stunningly beautiful but somewhat enigmatic nebula that we observe today. The material in the nebula is constantly being shaped by the force of the star's radiation and wind. The result is a complex and ever-changing structure, with clumps of gas being pushed outward while others are compressed together. This process of shaping is often referred to as photoevaporation, where the radiation from the stars effectively blows away parts of the nebula. Some of these regions may eventually become dense enough to form new stars or planets. However, this is a complex and highly chaotic process, and it is still unclear how often these types of stars and nebulae lead to the birth of new solar systems or planets. Nevertheless, Eta Carinae's nebula is a prime candidate for future studies on the complex interactions between massive stars, stellar winds, and the interstellar medium. Another significant factor in understanding the dynamics of Eta Carinae is its influence on the surrounding star-forming regions. While the exact mechanisms of star formation are still under investigation, it is believed that the energetic radiation and powerful winds from stars like Eta Carinae can trigger the formation of new stars and surrounding clouds of gas and dust. The force of the radiation from these massive stars can cause nearby gas clouds to collapse under their own gravity, leading to the birth of new stars. This is a phenomenon known as triggered star formation. The presence of Eta Carinae, with its extreme luminosity and its impact on the interstellar medium, may very well be playing a role in creating new stars in the broader Carinae Nebula. These interactions between stellar evolution, stellar winds, and the birth of new stars highlight the interconnectedness of the universe's processes, with one event potentially giving rise to another. In terms of the broader implications for stellar evolution, the study of Eta Carinae may offer us clues about the lives of stars in other parts of the galaxy. While Eta Carinae is an extraordinary example of a massive binary system, there are many other massive stars scattered throughout the galaxy and the universe. By studying Eta Carinae, astronomers can better understand the behavior of massive stars in a variety of environments. Whether they are in isolation or part of a binary system, the fundamental processes that govern the lives and deaths of these stars are likely to share many similarities. The study of this particular star system, with its dramatic outbursts and complex interactions, provides us with a valuable reference point for understanding the behavior of stars in different stages of their evolution. In the case of Eta Carinae, there is also a fascinating connection to the phenomenon of hypernovae. Hypernovae are exceptionally energetic supernova explosions that occur when extremely massive stars undergo a catastrophic collapse. These events are rare and difficult to study because they are so far beyond the ordinary supernova, which itself is a significant and often visible event in the sky. Hypernovae, however, represent a completely different scale of stellar explosion, and their aftermath can result in the formation of black holes or neutron stars. While it remains uncertain if Eta Carinae will end its life as a hypernova, its mass and ongoing behavior make it an intriguing candidate for such an outcome. If Eta Carinae does indeed end in a hypernova, it will likely have a profound impact on the surrounding interstellar medium. The explosion would release an incredible amount of energy and matter, sending shockwaves through the surrounding gas and dust. This explosion would further enrich the interstellar medium with elements such as iron, nickel, and other heavy elements, which would then become part of future star-forming regions. These elements are the building blocks of planets and life, and as such, a hypernova from Eta Carinae could ultimately contribute to the formation of new worlds, potentially even habitable ones. The role that massive stars like Eta Carinae play in seeding the universe with the elements necessary for life is an area of significant interest for astronomers and astrobiologists alike. In addition to these questions of stellar evolution and their broader cosmic effects, Eta Carinae's continued behavior provides a natural laboratory for the study of stellar atmospheres. The extreme conditions present in and around such a massive star system challenge our understanding of the processes that govern stellar atmospheres. The interactions between the radiation, magnetic fields, and stellar winds in Eta Carinae could offer valuable insights into the processes that occur in other stars. By studying the detailed physics of how the atmosphere of such a massive star behaves under these extreme conditions, scientists can refine their models of stellar structure and evolution, which will be essential for understanding the life cycles of stars in our galaxy. While the study of Eta Carinae's behavior has yielded a wealth of valuable information about the dynamics of massive stars, it has also highlighted just how much we have yet to learn. The star system's complexity, its binary nature, and its unpredictable outbursts continue to challenge astronomers in new and unexpected ways. With each new observation, we gain a clearer picture of the forces at work in this distant star system, but we are still far from understanding every facet of its life cycle. Eta Carinae stands as both a remarkable and mysterious object in the cosmos, and its future holds many secrets that we have yet to uncover. As our observational technologies continue to improve, the future of our study of Eta Carinae looks promising. The development of new space telescopes, such as the James Webb Space Telescope, will provide us with unprecedented views of the star system, allowing us to probe its atmosphere, its outbursts, and its surrounding nebula in greater detail than ever before. These advancements will enable scientists to gather critical data on the behavior of massive stars in their final stages of evolution, ultimately helping us piece together the larger story of stellar death and rebirth. Eta Carinae remains one of the most intriguing and mysterious objects in the universe. Its extraordinary outbursts, its binary dynamics, and its uncertain future all combine to make it a prime target for ongoing research and exploration. As we continue to study this remarkable star system, we not only gain insights into the life cycle of massive stars but also a deeper understanding of the cosmic forces that govern the evolution of galaxies, star systems, and even life itself. The journey to uncover the full story of Eta Carinae is far from over, and as our knowledge grows, so too will our appreciation for the breathtaking complexity of the universe. As we move forward in our exploration of Eta Carinae, the mystery surrounding its potential to explode as a supernova or even a hypernova continues to capture the imagination of astronomers and astrophysicists. This makes it an exceptional and somewhat eerie star system to study. The complexity of Eta Carinae's behavior challenges traditional models of stellar evolution and forces scientists to re-examine long-standing assumptions about the life cycles of massive stars. To understand why Eta Carinae stands as a pivotal object for research, we must delve deeper into the theoretical underpinnings of stellar collapse and the processes that lead to such powerful cosmic events. At the heart of stellar death lies the question of what causes a star to undergo such a dramatic transformation. For most stars, death occurs when they exhaust their nuclear fuel, leading to a collapse under their own gravity. However, in the case of Eta Carinae, this process is complicated by the fact that the system consists of two massive stars, each pushing and pulling on each other with extraordinary force. The interaction between these stars has significant consequences for their eventual fate. It is believed that the binary nature of the system may alter the typical path to stellar death, with one star potentially stripping material from the other, adding another layer of complexity to the system's future. The sheer mass of the primary star in the system suggests that it will eventually run out of fuel, entering the final stages of its life. But the real question is, what happens after that? The explosion of a supernova is not a given in all massive stars. In many cases, massive stars end their lives by shedding their outer layers in a massive outburst, without a full collapse into a black hole or neutron star. However, in the case of Eta Carinae, the possibility of a hypernova event adds an additional layer of intrigue. A hypernova is an exceptionally energetic explosion that occurs when a particularly massive star collapses, releasing an immense amount of energy and matter into space. This is far more energetic than the typical supernova explosion and often leads to the formation of a black hole. The discovery of Eta Carinae's great eruption in the 19th century added yet another layer of complexity to the question of its future. The eruption, which was observed by astronomers during the 1800s, was an event unlike any other in recorded history. The eruption lasted for years and released enormous amounts of energy, suggesting that the system was undergoing a violent phase of instability. The phenomenon was so bright that it outshone the entire Milky Way for a time, becoming one of the most luminous stars in the sky. Since then, Eta Carinae has continued to show signs of intense activity, with periodic outbursts and changes in luminosity that indicate the system is far from stable. These eruptions have only fueled the speculation about what lies ahead for the star system. One possible explanation for these outbursts is that the stars in the binary system are interacting in a way that leads to periodic periods of extreme instability. As the stars orbit each other, their mutual gravitational influence could be causing them to shed material, resulting in dramatic changes in their luminosity. This could explain why Eta Carinae has experienced multiple outbursts over the centuries, with the Great Eruption being the most well-known event. However, the exact mechanism behind these eruptions remains unclear, and it is still a subject of intense study. Some scientists speculate that the eruptions may be the result of the stars in the system undergoing a series of rapid changes in their internal structure, leading to sudden bursts of energy and matter. Understanding the mechanism behind these outbursts is crucial for understanding the eventual fate of Eta Carinae. If the system continues to experience such violent eruptions, it could eventually lead to the complete disruption of the star system. However, it is also possible that these outbursts are a sign of the star system nearing the end of its life. As the primary star runs out of fuel and begins to collapse, the immense pressure could trigger a series of catastrophic events, culminating in a hypernova explosion that would release more energy than the rest of the galaxy combined. The potential for such an event raises important questions about the broader implications for the surrounding region of space. The energy released by a hypernova could have profound effects on the interstellar medium, influencing the formation of nearby stars and potentially even altering the dynamics of galaxies. The shockwaves from such a violent explosion would propagate through the surrounding gas and dust, causing it to compress and heat up, potentially triggering new star formation. The enriched elements released by the explosion would also become part of the interstellar medium, contributing to the creation of new stars and planets in the future. In this way, the death of Eta Carinae could play a significant role in the broader cosmic cycle of birth and death. Despite the uncertainty surrounding Eta Carinae's eventual fate, its status as one of the most massive and energetic star systems in the galaxy makes it a key object of study. The star system offers a unique window into the processes that govern the evolution of massive stars and the fate of the most extreme stellar objects in the universe. By studying Eta Carinae, astronomers can gain valuable insights into the mechanisms behind stellar explosions, the formation of black holes, and the complex dynamics of binary star systems. Furthermore, the lessons learned from studying this enigmatic star system can help us understand the broader processes at work in the universe, from the birth of new stars to the death of massive stellar objects. One of the most exciting aspects of the ongoing research into Eta Carinae is the role that new technological advancements are playing in deepening our understanding of the system. Over the past few decades, the development of more sophisticated telescopes and observational instruments has allowed scientists to gather more detailed data on the system than ever before. Instruments such as the Hubble Space Telescope and the Chandra X-ray Observatory have provided critical insights into the structure of the nebula surrounding Eta Carinae, as well as the behavior of the stars within the system. These observations have revealed fascinating details about the dynamics of the system, including the interaction between the stellar winds and the surrounding gas, the structure of the nebula, and the patterns of material ejected by the stars. The James Webb Space Telescope, set to launch in the coming years, will provide even more detailed views of Eta Carinae and other massive star systems. The infrared capabilities of the James Webb Telescope will allow scientists to peer through the thick clouds of dust and gas that surround the system, offering a clearer view of the stars and their interactions. This new data will undoubtedly shed light on the complex processes taking place within the system, offering crucial clues about the eventual fate of the stars and the nebula surrounding them. In addition to the advancements in observational technology, the continued development of theoretical models is helping to refine our understanding of the processes that govern the life cycle of massive stars. Scientists are working to create more accurate simulations of stellar evolution, taking into account the complexities of binary star systems and the interactions between massive stars and their surrounding environments. These models are essential for predicting the future behavior of stars like Eta Carinae and for understanding the broader implications of their death. As we look to the future, Eta Carinae will undoubtedly remain a subject of intense study. Whether it ends its life in a spectacular hypernova or undergoes a more gradual transformation, the star system holds the key to unlocking many of the mysteries surrounding massive stars and their role in the universe. Its story is far from over, and as our technology and understanding continue to advance, we can expect even more thrilling discoveries in the years to come. Eta Carinae stands as one of the most captivating and mysterious star systems in the cosmos. Its dramatic outbursts, its binary dynamics, and its uncertain future all combine to make it a key object of study for astronomers seeking to understand the life cycle of massive stars. Whether it eventually explodes as a supernova or hypernova, or undergoes a more gradual transformation, the impact of its death will be felt throughout the surrounding interstellar medium. By continuing to study this remarkable star system, scientists are gaining valuable insights into the processes that govern stellar evolution and the broader dynamics of the universe. Eta Carinae, despite being one of the most enigmatic stellar systems in our galaxy, holds profound significance for the field of astrophysics. As we continue to look deeper into the life of this star system, its eventual fate promises to offer profound insights not just into the mechanics of massive stars, but also into the larger workings of the universe. The ongoing observations of Eta Carinae highlight an interesting paradox. Despite being so far from Earth, roughly 7,500 light-years away, it feels like a cosmic neighbor, constantly revealing new secrets to eager astronomers and astrophysicists. It is important to note that Eta Carinae's future demise is not just a matter of academic interest. The explosion of a star as massive as this could have far-reaching consequences, not just for the surrounding space but potentially for the regions within its vicinity. The radiation from such an explosion could provide new insights into the mechanisms of star formation, galaxy evolution, and the chemical enrichment of the universe. Stellar explosions like supernovae and hypernovae play a central role in seeding the universe with heavy elements that are essential for the formation of planets and life as we know it. Understanding how Eta Carinae's explosive demise may unfold is not only crucial for studying stellar evolution but also for understanding the broader cosmic ecosystem that sustains life itself. With each observation of Eta Carinae, scientists grow more confident that the star's eventual death will not be a simple affair. Given its mass and the energy it has already released, there is a strong possibility that it will not simply go out with a bang, but with a series of dramatic eruptions, ultimately culminating in a massive explosion. While much of the focus has been on Eta Carinae's massive outbursts and its potential for a supernova or hypernova, researchers are also studying the way the star system surrounding nebula is evolving in response to these violent events. The interaction between the massive star's outflows and the surrounding gas cloud is a dynamic process that contributes to the overall star formation environment of the region. This feedback mechanism plays a pivotal role in shaping the future of the star-forming regions within the Milky Way and possibly even in galaxies beyond our own. As Eta Carinae ejects material during its explosive phases, it contributes to the enrichment of the interstellar medium with heavy elements such as oxygen, nitrogen, and iron. These elements are key components of planets and life itself, making the study of Eta Carinae's interactions with its environment critical to understanding how the building blocks of life are spread throughout the galaxy. The star system's violent eruptions serve as a cosmic forge, shaping the very elements that give rise to future stars, planets, and possibly even life. Another fascinating aspect of Eta Carinae's great eruption and its subsequent behavior is how it challenges our understanding of mass loss in massive stars. The outbursts observed in the 19th century were so intense that they led to significant changes in the surrounding nebula. While massive stars do experience significant mass loss during their lifetimes, Eta Carinae's rate of mass loss appears to be far beyond typical stellar norms. Some theorists suggest that this could be a result of the binary interaction within the system, where one star strips material from the other. This mass transfer process might be contributing to the extreme instability observed in the system. Understanding this process in more detail will help astronomers better understand the different ways in which stars can shed their outer layers and how these mass loss events might influence the star's evolution and eventual death. As we look to the future of studying Eta Carinae, it's worth considering the potential for even more advanced technologies to provide clearer and more detailed views of the system. The new generation of space telescopes, like the James Webb Space Telescope, has the potential to revolutionize our understanding of stars like Eta Carinae. With its infrared capabilities, Webb will allow scientists to peer through the dust and gas that obscure our view of the system, offering unprecedented views of the star itself and the surrounding nebula. This could allow researchers to observe the behavior of the system in real time, offering critical insights into the mechanics of stellar outbursts, mass loss, and the eventual fate of the stars involved. The data collected by Webb, combined with the continuing work of astronomers and astrophysicists, will help to refine our models of massive star systems and provide new insights into the physics of stellar explosions. But beyond the technology and research, Eta Carinae serves as a reminder of the wonders and mysteries that still await us in the universe. The sheer scale and energy of this star system are humbling, and its eventual death will undoubtedly be a momentous event in the life of our galaxy. The death of such a massive star will not just be the end of a single object, but rather the transformation of the material that once formed it. The elements produced in the explosion will be dispersed into the surrounding region, enriching the interstellar medium and helping to create the next generation of stars, planets, and possibly even life. Eta Carinae's ultimate fate will be a key chapter in the ongoing story of the universe's evolution, and it's a story that is far from over. The scientific community eagerly watches Eta Carinae, knowing that every observation brings us closer to unlocking the many mysteries surrounding this extraordinary star system. With each passing year, new data and breakthroughs emerge, and our understanding of the system continues to evolve. The great eruption that took place in the 19th century is just one chapter in a much larger narrative, one that continues to unfold before our eyes. The next stages in the life of Eta Carinae are still unknown, but what we do know is that its eventual demise will be one of the most significant cosmic events to witness. Eta Carinae is a beacon of discovery for astrophysicists. Its outbursts, potential for explosive death, and profound influence on the surrounding environment make it a star unlike any other. The continued study of this celestial enigma will not only teach us about the life and death of stars but will also expand our understanding of the universe itself. Its violent eruptions and the complex dynamics of its binary system challenge everything we thought we knew about massive stars and their ultimate fates. As we move into the next era of astronomical research, Eta Carinae will undoubtedly remain one of the most captivating and scientifically important objects in the sky. Through continued observation and technological advancement, the future of our understanding of this star system looks brighter than ever, and we can only wait with bated breath to see what secrets Eta Carinae will reveal next. As we continue to explore Eta Carinae, it is worth revisiting the broader context in which this star system exists. Eta Carinae is not a solitary anomaly in the universe. Rather, it is part of a larger class of massive stars, each of which plays a vital role in the life cycle of galaxies. Massive stars, such as those in the O-type and Wolf-Rayet categories, are some of the most luminous and energetic objects in the universe. The unique behavior of Eta Carinae, particularly its extraordinary outbursts, underscores the complexity of massive star systems and highlights the need for a deeper understanding of their behavior. One of the most intriguing aspects of Eta Carinae's life cycle is the way it defies conventional stellar expectations. Stars that are nearing the end of their lives typically experience gradual cooling and shedding of mass before they reach their final explosive phase. However, Eta Carinae has taken an entirely different path, experiencing multiple outbursts over a relatively short period of time. This unpredictability raises the question of whether traditional models of stellar evolution are fully equipped to explain the behavior of such massive stars. Could there be factors at play in Eta Carinae's system that we have not yet identified? The study of Eta Carinae, with its complex interaction between a massive primary star and its binary companion, may unlock new theories in stellar physics that could revolutionize our understanding of not just this star, but of other stars in the same class. Eta Carinae's binary system is central to its fascinating behavior. As mentioned, the star is a binary system consisting of at least two massive stars. The primary star, a hypergiant that is among the largest and most luminous known, is surrounded by a dense cloud of gas and dust created by its own mass loss. The second star, a massive blue giant, orbits closely enough to interact with the primary star's outer layers, contributing to the system's irregular outbursts. This close binary interaction is thought to play a significant role in the massive eruptions observed in the system. The interaction between the two stars likely creates periodic bursts of mass loss, as one star strips material from the other, resulting in intense radiation and the formation of vast nebulae around the system. These stellar interactions also shed light on the potential for other binary systems across the universe, suggesting that a significant portion of massive stars are not solitary objects, but rather part of interacting pairs that influence one another's behavior. Understanding the mechanisms at play in systems like Eta Carinae will provide valuable insight into the dynamics of stellar evolution in general. Another area of intense research is the behavior of the surrounding nebula, which is composed of material ejected by the massive stars. This nebula is constantly changing in response to the intense energy and radiation emitted by the stars within the system. The complex structure of the nebula has been the subject of much investigation, particularly in relation to how it interacts with the surrounding interstellar medium. By observing the nebula, astronomers can gain important clues about the life cycle of the stars and the processes that lead to the formation of elements essential for life. Eta Carinae's nebula is also home to other interesting phenomena, such as the presence of so-called bow shocks. These structures, which resemble the wake of a boat moving through water, are created by the intense radiation pressure and stellar wind emanating from the stars in the system. As the stars move through the surrounding interstellar gas, they create shockwaves that compress and shape the surrounding material, creating beautiful, intricate patterns. These bow shocks are just one example of how Eta Carinae's explosive activity is affecting the interstellar environment, contributing to the ongoing process of star formation. In addition to providing insight into the mechanics of massive stars, the study of Eta Carinae and its surrounding nebula also offers important clues about the broader processes of galaxy evolution. The death of massive stars plays a key role in the evolution of galaxies, particularly in terms of the chemical enrichment of the interstellar medium. When massive stars explode in supernovae or hypernovae, they release vast quantities of heavy elements into the surrounding space. These elements, including iron, oxygen, and carbon, are essential for the formation of planets and life as we know it. Understanding how stars like Eta Carinae contribute to this cosmic recycling process is crucial for understanding the long-term evolution of galaxies and the creation of the building blocks of life. In recent years, astronomers have begun to investigate whether the energetic outbursts from Eta Carinae might influence the formation of new stars in the region. The intense radiation and shockwaves produced by the star's outflows could trigger the collapse of nearby molecular clouds, leading to the birth of new stars. This feedback mechanism, where the death of one generation of stars gives rise to the next, is a key process in the life cycle of galaxies. By studying systems like Eta Carinae, astronomers can gain a better understanding of how star formation is regulated and how the energy from massive stars can shape the structure of galaxies over time. In addition to its scientific importance, Eta Carinae has captured the imagination of the public and inspired countless theories and speculations about the fate of the star system. Its status as a potential future supernova or hypernova has made it a popular subject for science fiction, where it is often depicted as a harbinger of cosmic destruction. While the reality of Eta Carinae's future is still unknown, its sheer scale and energy are undeniably awe-inspiring. The possibility of witnessing the death of such a massive star, whether through a dramatic supernova explosion or through a more gradual process, is an exciting prospect for astronomers and stargazers alike. As we continue to explore the mysteries of Eta Carinae and other massive stars, we are reminded of the vastness of the universe and the incredible forces at play in the cosmos. Eta Carinae's outbursts and eventual death will have a profound impact on the surrounding region, contributing to the ongoing cycle of star formation and enriching the interstellar medium with the elements needed for future generations of stars, planets, and life. The study of this remarkable star system provides us with valuable clues about the nature of stellar evolution, the life cycle of galaxies, and the fundamental processes that govern the universe. The future of Eta Carinae, as well as our ability to observe and study it, will be shaped by the technological advances of the coming decades. The launch of space telescopes like the James Webb Space Telescope marks a new era in our ability to peer into the heart of star systems like Eta Carinae, providing unprecedented views of the star and its surroundings. As we continue to probe the mysteries of this remarkable system, we can only wonder what new discoveries will emerge. Will Eta Carinae's explosive demise be as spectacular as astronomers expect, or will it reveal new and unexpected behaviors that challenge our understanding of stellar death? Only time will tell, but one thing is certain: the study of this extraordinary star system will continue to captivate the scientific community and inspire generations of astronomers and stargazers to look to the heavens in search of answers to the most fundamental questions of the universe. As we continue our exploration of Eta Carinae, we begin to realize that the insights we gain from this star system not only help us understand the life cycle of massive stars, but also push the boundaries of modern astrophysics. The more we study stars like Eta Carinae, the more we encounter peculiarities that challenge established theories, prompting a reevaluation of how we think about stellar evolution, energy production, and the dynamics of star systems. A fundamental aspect of Eta Carinae's behavior that continues to captivate astronomers is its periodic outbursts. Unlike typical massive stars, which undergo relatively predictable phases of evolution, Eta Carinae's violent outbursts have been marked by periods of intense activity, followed by periods of quiescence. This variability in its luminosity and mass loss is not something we fully understand, and it raises intriguing questions about the internal processes at play within the star itself. What causes a star to shed material in such an unpredictable manner? Is it related to some form of stellar instability, or could external factors, like the influence of its binary companion, be playing a larger role than we have previously considered? The study of these outbursts provides critical data that could eventually lead to new models of massive star behavior. In particular, astronomers are interested in whether these eruptions could be the result of an unstable fusion process in the star's core. When stars of this size approach the end of their lives, they undergo complex nuclear reactions that can lead to changes in their internal structure. In some cases, this can cause the star to experience sudden, dramatic shifts in brightness and mass loss. Eta Carinae's behavior might be a preview of the sorts of events that occur in the final stages of stellar evolution, as it struggles to maintain equilibrium before its ultimate collapse. The connection between Eta Carinae's binary nature and its explosive activity also provides crucial clues. The primary star, an exceptionally massive and hot hypergiant, interacts with its companion, a blue giant, in a way that amplifies its outbursts. This kind of close binary interaction is thought to play a significant role in shaping the system's behavior, and understanding the dynamics of such interactions could help us explain why some stars seem to experience dramatic outbursts, while others remain relatively stable. The gravitational pull between the two stars could be causing tidal forces that destabilize the primary star, triggering massive eruptions of gas and dust. These interactions also highlight how binary systems are essential to the life cycles of many massive stars, potentially giving us a broader understanding of stellar evolution. Furthermore, Eta Carinae's dramatic outbursts and its eventual fate have profound implications for the surrounding interstellar medium. When massive stars like Eta Carinae release material into space, they contribute to the enrichment of the surrounding environment, infusing it with heavy elements that will later form new stars, planets, and even life. The explosions and mass loss from Eta Carinae are not just important for understanding the star itself, but they also represent a fundamental part of the cosmic cycle of life and death in the universe. This stellar recycling process is vital for the formation of future generations of stars, and by studying it in the context of Eta Carinae, we can better understand the long-term evolution of galaxies. Moreover, the outbursts of Eta Carinae provide a perfect opportunity to study the formation of nebulae and other cosmic structures. The ejected material from the star creates a nebula that is constantly changing and evolving in response to the star's radiation and stellar winds. This nebula, known as the Homunculus Nebula, is one of the most beautiful and intricate structures in the sky, filled with intricate filaments of gas and dust shaped by the intense energy radiated from Eta Carinae. As we observe the nebula, we learn not only about the life cycle of stars but also about the way cosmic material is shaped and influenced by the forces of stellar evolution. The Homunculus Nebula's ever-changing nature provides astronomers with a unique window into the forces that govern the birth and death of stars, offering a glimpse into the violent processes that occur as massive stars shed their outer layers. In recent years, the increasing sensitivity of telescopes like the Hubble Space Telescope and the ALMA Array has enabled astronomers to study Eta Carinae with unprecedented detail. These advanced instruments are allowing scientists to observe the star system in multiple wavelengths, from ultraviolet to infrared, providing a comprehensive view of its behavior and environment. With these tools, astronomers can now probe the structure of the star's surrounding nebula, track its outbursts, and even analyze the motion of its binary companion. This level of detail is providing scientists with invaluable data that will inform our understanding of not just Eta Carinae, but also the broader processes that govern the evolution of massive stars throughout the universe. In addition to its scientific importance, Eta Carinae has become a symbol of the unknown, representing the incredible complexity and mystery that still exists within our understanding of the cosmos. Its behavior is so unlike that of other stars, and its eventual fate is so uncertain, that it embodies the ultimate challenge for astronomers: to unlock the secrets of a star system that seems determined to defy our understanding of stellar physics. As we continue to study this enigmatic star, we are confronted with the humbling reality that there is so much we still don't know about the universe. Eta Carinae, with its explosive outbursts and unpredictable behavior, serves as a reminder of the vast unknowns that remain in the field of astrophysics. For those who wonder what the future holds for Eta Carinae, one thing is certain: its eventual death will be a spectacular event. Whether it ends its life in a massive supernova explosion or through some other process, the end of Eta Carinae will mark the conclusion of a star's journey through the universe. But even in its death, Eta Carinae will continue to play a vital role in shaping the future of the galaxy. The material it ejects will enrich the interstellar medium, providing the raw materials for the formation of new stars and planets. And just as stars like Eta Carinae give birth to new generations of stars, they also provide the elements necessary for the creation of life. Thus, the death of Eta Carinae will not be an end, but rather a new beginning in the ongoing cycle of stellar evolution. As we look to the future, the study of Eta Carinae promises to be an ongoing journey of discovery. With new technological advancements, such as the James Webb Space Telescope, offering unprecedented views of the star and its surroundings, we are poised to learn even more about this fascinating and enigmatic system. The mysteries of Eta Carinae, with its violent outbursts, its role in the creation of cosmic structures, and its eventual death, will continue to captivate astronomers and stargazers for generations to come. Through continued research, we may finally unlock the full story of this remarkable star system, gaining insights into the very processes that shape the universe itself. Continuing our deep dive into the mysteries of Eta Carinae, we realize that while much has been learned, many questions remain unanswered. The more we explore this stellar system, the more we understand how extraordinary it is, not only for its explosive behavior but also for the potential answers it holds to broader astrophysical questions. Eta Carinae is not just an isolated phenomenon, it's a window into the larger workings of the cosmos, and in studying it, we may uncover vital truths that reshape our understanding of the universe. The very size and mass of the star at the heart of Eta Carinae are part of what makes it so significant to astronomers. The star, known as Eta Carinae, is roughly 100 times the mass of our Sun, and it's a supermassive hypergiant that burns through its fuel at an incredibly fast rate. These massive stars, though rare, play a critical role in the life cycle of the universe. Their explosive deaths in supernovae or other catastrophic events scatter heavy elements, such as iron, carbon, and oxygen, into space. These elements are essential for the formation of new stars, planets, and life, which means that stars like Eta Carinae are fundamentally linked to the evolution of the universe itself. However, because they burn through their fuel so quickly, they also have short lifespans. Eta Carinae's current behavior suggests that it is nearing the end of its life cycle. Yet, its unpredictability makes it hard to say when or how it will reach its inevitable demise. The outbursts of Eta Carinae, as we have seen, are staggeringly powerful. At least 2 massive eruptions have been recorded in the star's recent history, with the most notable occurring in the 19th century. These eruptions left behind the Homunculus Nebula, a strange, intricate structure that still fascinates scientists today. The nebula itself is a complex, bipolar cloud of gas and dust that has been shaped by the intense energy and stellar winds of the central star. The Homunculus Nebula is constantly evolving and changing, as the material it contains interacts with the radiation and pressure from the star. These changes are visible even to the naked eye through telescopes, and they have provided a unique opportunity for astronomers to study the process of nebula formation in real time. The nebula is a byproduct of the star's erratic behavior, and studying it helps astronomers understand not only the life cycle of stars like Eta Carinae but also the processes that lead to the formation of galaxies and other cosmic structures. What makes this star system even more fascinating is its interaction with its binary companion, which also plays a key role in shaping the dynamics of the system. Eta Carinae is part of a binary system with Eta Carinae b, a massive blue giant that is thought to be nearly as massive as the primary star. The two stars are in such close proximity that their mutual gravitational forces create a dynamic and turbulent relationship. The interaction between the two stars has likely contributed to the erratic outbursts of Eta Carinae, with the gravitational pull of the companion star potentially inducing tidal forces that destabilize the massive hypergiant. The effects of these forces on the two stars, along with the material they both eject into space, have created a highly dynamic and constantly changing environment within the system. The study of such binary star systems is crucial, as it allows scientists to observe how stars interact with one another, and how these interactions influence the life cycle of each star involved. These binary star systems, such as Eta Carinae, are not uncommon in the universe. In fact, a significant percentage of stars in the galaxy are believed to exist in binary or even multiple star systems. The complexities that arise from the gravitational interactions in these systems are essential to understanding stellar evolution, as they can significantly alter the way in which stars evolve. Eta Carinae provides us with a perfect laboratory to study these complex interactions, offering insights into how stars in close proximity influence one another's behavior. This knowledge could have broader implications for our understanding of other stellar systems in the galaxy, helping us to better predict the fate of stars like the Sun, as well as those that are far more massive and extreme. Despite our growing understanding of Eta Carinae and its outbursts, many questions remain. For example, while astronomers have observed dramatic changes in the star's brightness, they are still uncertain about the exact mechanisms driving these fluctuations. Some theories suggest that the star undergoes periods of unstable nuclear fusion within its core, which could cause massive variations in luminosity. Others believe that the cause could be related to magnetic fields or other internal processes, but the truth remains elusive. This uncertainty underscores the complexity of the phenomena we are observing and highlights how much more there is to discover about stars like Eta Carinae. Another major question revolves around the ultimate fate of the Eta Carinae system. The star is likely to end its life in a violent explosion, but whether this will take the form of a supernova, a hypernova, or some other catastrophic event is still a matter of debate. If the star does indeed undergo a supernova, The resulting explosion would be one of the most spectacular events in the universe. It would release an enormous amount of energy, potentially outshining an entire galaxy for a brief period of time. This explosion would also create a shockwave that would spread throughout the surrounding interstellar medium, enriching it with heavier elements. The remnant core of the star could collapse into a neutron star or even a black hole, depending on the final mass of the core. Alternatively, if the star undergoes a more gradual collapse, it could end its life as a faint white dwarf surrounded by a nebula. These possibilities make the fate of Eta Carinae both intriguing and uncertain, and astronomers are keenly watching for any signs that could provide clues about what will happen next. One of the most exciting prospects for the study of Eta Carinae lies in the future of astronomical technology. With the advent of next-generation telescopes, such as the James Webb Space Telescope, JWST, astronomers will have unprecedented access to the star system in various wavelengths, including infrared, which will allow them to peer into the dense clouds of gas and dust surrounding the system. This could provide a more detailed understanding of the internal processes taking place within the star, as well as how the surrounding nebula is evolving over time. The JWST's capabilities will also help scientists study the atmosphere of Eta Carinae's binary companion, potentially revealing how the two stars are interacting on a deeper level. Another tool that promises to revolutionize our understanding of Eta Carinae is the use of gravitational wave detectors. These instruments, such as the Laser Interferometer Gravitational Wave Observatory, LIGO, are designed to detect ripples in space-time caused by the collision and merger of massive objects, such as black holes and neutron stars. Although no gravitational waves have yet been detected from Eta Carinae, the potential for this to happen in the future is high. If the system undergoes a supernova or other catastrophic event, it could send gravitational waves rippling across space, providing astronomers with another powerful way to study the star's final moments. Gravitational wave astronomy is still in its infancy, but it holds enormous potential for enhancing our understanding of not just Eta Carinae, but the broader universe. Eta Carinae is one of the most fascinating and enigmatic star systems known to science. Its massive size, unpredictable outbursts, and potential for future cataclysmic events make it a subject of intense study for astronomers and astrophysicists. From its binary companion to the complex processes at work within its core, Eta Carinae challenges our understanding of stellar evolution and pushes the boundaries of what we know about the cosmos. With the help of advanced astronomical instruments, we are beginning to unlock the secrets of this incredible star system, but the full story of Eta Carinae is far from being told. As we continue to observe its behavior and study its unique properties, we are reminded of the vast mysteries that still await us in the universe, and how much more we have to learn about the stars that light up the night sky. As we continue to study Eta Carinae, it becomes increasingly clear that this star system is not just a curiosity, but a key to understanding some of the most fundamental processes that govern the life cycle of stars. Eta Carinae challenges our understanding of stellar evolution and forces us to reconsider many of the assumptions we have about how stars live, die, and interact with their environments. By studying this system, we are essentially peering into a cosmic laboratory where stars undergo their most extreme behaviors, and the lessons learned here will undoubtedly have a ripple effect throughout the field of astrophysics. One of the most pressing questions surrounding Eta Carinae is the nature of its extreme variability. As mentioned, the star is notorious for its outbursts, which have been observed in both the 19th century and more recently, in the early 2000s. These outbursts are incredibly violent, and can cause the star's luminosity to fluctuate wildly. The primary cause of these eruptions is still a matter of active research. Some astronomers speculate that Eta Carinae's variability is due to the presence of a massive convective layer beneath its outer atmosphere. This layer could cause the star's outer layers to expand and contract unpredictably, leading to large-scale eruptions. Others propose that the outbursts may be the result of the binary system's interactions, where the material from one star is drawn toward the other, causing significant changes in both stars' behavior. In any case, Eta Carinae's variability is an area of intense study, as understanding its mechanics could help scientists unravel the mysteries of other stars with similar behavior. The composition of the surrounding nebula, the Homunculus Nebula, also offers crucial clues to understanding the processes taking place in the Eta Carinae system. The nebula itself is rich in heavy elements, and shows clear signs of having been shaped by the intense radiation and stellar winds from Eta Carinae. This interaction between the star and its surrounding nebula is a common feature in the lives of massive stars. The strong stellar winds push away material from the star, creating an expanding bubble of gas and dust. This material can then form complex structures, such as the intricate lobes of the homunculus nebula, which are a direct result of Eta Carinae's periodic outbursts. The study of this nebula offers a rare opportunity to observe how a massive star interacts with its environment, and how it shapes the space around it. Moreover, the study of Eta Carinae provides valuable insights into the processes of star formation. In regions of space where massive stars like Eta Carinae are born, the intense radiation and stellar winds can trigger the formation of new stars and planetary systems. The shockwaves produced by Eta Carinae's eruptions could potentially compress nearby clouds of gas and dust, creating the conditions necessary for the birth of new stars. These processes are thought to be responsible for the creation of many of the stars and planetary systems we observe in the universe today. By studying how Eta Carinae's eruptions affect its surroundings, we can gain a better understanding of how stars form and evolve in regions of intense stellar activity. On a larger scale, Eta Carinae's behavior may help us to understand the role that massive stars play in the evolution of galaxies. When a massive star like Eta Carinae explodes in a supernova, it releases an enormous amount of energy into its surrounding environment. This explosion enriches the interstellar medium with heavy elements, which then become incorporated into future generations of stars and planets. This process is an essential part of the cosmic cycle, and understanding how massive stars like Eta Carinae contribute to the enrichment of the universe is a key area of study. Moreover, these massive stars can also influence the dynamics of their host galaxies by triggering the formation of new stars or by causing the collapse of molecular clouds. In this sense, the study of Eta Carinae is not just about understanding one star, but about gaining insight into the broader processes that shape the evolution of galaxies themselves. While Eta Carinae has provided us with many answers, it has also raised more questions than we could have imagined. The star's unpredictable behavior challenges our understanding of the physics of massive stars. We have a general understanding of how stars evolve based on their mass, but Eta Carinae is pushing the boundaries of this knowledge. It is a reminder that our understanding of the universe is still in its infancy, and there is so much more to learn. This sense of mystery and uncertainty is part of what makes studying Eta Carinae, and stars like it, so compelling. It reminds us that space is full of phenomena that we don't yet fully comprehend, and it is this sense of wonder that drives scientific exploration. In recent years, technological advancements have enabled scientists to gain a more detailed understanding of Eta Carinae than ever before. The launch of advanced space telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, has allowed astronomers to observe the star system in unprecedented detail. These telescopes have provided high-resolution images of the Homunculus Nebula and the surrounding space, revealing intricate features that were previously invisible to ground-based telescopes. The ability to study Eta Carinae in multiple wavelengths of light, from ultraviolet to infrared, has also revealed new information about the star's behavior and the structure of the surrounding nebula. In particular, the James Webb Space Telescope, with its infrared capabilities, is expected to provide even more detailed observations of the star system, allowing astronomers to study the star's atmosphere, the nebula, and the surrounding environment with greater clarity. The insights gained from these observations could help scientists answer many of the lingering questions about Eta Carinae. For example, by studying the light emitted by the star, astronomers may be able to determine the composition of its outer layers and gain insights into the processes occurring within its core. Additionally, the detailed images provided by these telescopes could help scientists understand the dynamics of the Homunculus Nebula and how it has been shaped by the star's outbursts. Ultimately, these observations will help to refine our understanding of the life cycle of massive stars and their role in the broader evolution of the universe. Eta Carinae's mysteries extend beyond the bounds of the star system itself. Its unpredictability has inspired awe and wonder in both professional scientists and amateur astronomers alike. It serves as a reminder that the universe is filled with phenomena that challenge our understanding of the laws of physics and the nature of existence. Stars like Eta Carinae are not only awe-inspiring in their scale and power, they are also key to unlocking the secrets of the universe. As we look to the future, it is clear that Eta Carinae will continue to be a focal point for research and discovery. Its behavior will likely remain unpredictable, and it will likely continue to surprise us with new and unexpected phenomena. Whether through the use of new telescopes, advanced computational models, or even space-based observatories dedicated to studying stellar systems like Eta Carinae, we can expect that the mystery of this star will only deepen. It will remain a shining example of the complexity and beauty of the universe, inviting us to keep looking up at the stars in wonder, knowing that there is so much left to discover. In the grand scheme of things, Eta Carinae is just one star among countless others in the cosmos. But its extraordinary behavior and the mysteries it presents make it one of the most fascinating objects of study in the universe. Through the continued exploration of Eta Carinae, we are not just learning about one star, we are uncovering the broader processes that govern the cosmos, and in doing so, we are advancing our understanding of the universe itself. This journey into the unknown is one of the most exciting frontiers of modern science, and Eta Carinae is leading the way. As we continue to unravel the mysteries surrounding Eta Carinae, we must recognize the broader significance of studying such an enigmatic system. This star is not only an object of fascination because of its unpredictable outbursts and immense size, but because it plays a crucial role in understanding the life cycle of massive stars. The insights gleaned from this system allow astronomers to test the theories of stellar evolution, offering a glimpse into what happens in the final stages of a star's existence, and how it can influence its surroundings. One of the most intriguing aspects of Eta Carinae is its ability to defy the typical life cycle of a star. Most massive stars, after exhausting their nuclear fuel, undergo a supernova explosion, collapsing into either a neutron star or black hole. However, Eta Carinae's behavior is far more complex. Its periodic eruptions have led some astronomers to wonder if the star might eventually collapse in a way that is entirely unexpected. Some scientists speculate that Eta Carinae may be on its way to becoming a hypernova, a type of supernova associated with the death of especially massive stars. A hypernova produces far more energy than a typical supernova and is often linked with the formation of black holes. If this hypothesis proves true, Eta Carinae's final demise could be far more dramatic than anything we've witnessed in the cosmos. Moreover, Eta Carinae's role in the wider astrophysical community goes beyond its eventual fate. The violent eruptions that the star experiences could have important consequences for the surrounding interstellar medium. When Eta Carinae expels massive amounts of material during its outbursts, it enriches the surrounding space with heavy elements such as carbon, oxygen, and nitrogen, elements that are essential for the formation of life. This process of stellar enrichment, where the materials ejected by a dying star help to form new generations of stars and planets, is one of the most fundamental aspects of cosmic evolution. The explosions of massive stars like Eta Carinae act as a recycling mechanism, ensuring that the elements needed for life are spread throughout the galaxy, where they can be incorporated into future star systems. The impact of Eta Carinae's eruptions is not confined to the immediate area around the star. In fact, the shockwaves generated by these outbursts may affect the evolution of nearby stars and planetary systems. Some researchers suggest that the powerful radiation and stellar winds from Eta Carinae could trigger the formation of new stars. The energy released by the star's outbursts could compress nearby gas clouds, leading to the birth of new stellar clusters. This process, known as triggered star formation, occurs when the intense pressure from a nearby explosion causes a dense region of gas to collapse, giving birth to new stars. It's a remarkable example of how the death of one star could lead to the creation of many others, and perhaps even give rise to new planetary systems. Additionally, the binary nature of the Eta Carinae system adds another layer of complexity to the study of stellar evolution. Eta Carinae is composed of two stars, the massive primary star, which is one of the most luminous stars known, and its companion, a less massive but still substantial star. The gravitational interaction between these two stars has profound effects on both their behavior and the structure of the surrounding nebula. As the stars orbit one another, they exert tidal forces on each other, causing their shapes to become distorted and their atmospheres to interact in fascinating ways. This interaction could also be the driving force behind the periodic outbursts observed in the system. The complex dynamics of binary star systems like Eta Carinae provide important insights into how stars evolve, interact, and ultimately die. In addition to the astrophysical phenomena taking place within the system, the study of Eta Carinae has implications for the broader understanding of the universe itself. For one, it forces scientists to reconsider the limitations of their current models of stellar evolution. Eta Carinae's unpredictability, its tendency to behave in ways that contradict established theories, has prompted astrophysicists to develop new models that can better account for such anomalous behavior. This process of refining and updating our understanding of stellar life cycles has broad implications for our knowledge of the cosmos, as it affects how we interpret the behavior of other stars and stellar systems. Furthermore, the study of Eta Carinae has broader implications for our understanding of the universe's history. By studying the remnants of massive stars like Eta Carinae, astronomers can learn about the conditions that existed in the early universe. The elements ejected by supernovae and hypernovae, for example, were critical in shaping the formation of galaxies, stars, and planetary systems. By studying these processes in stars like Eta Carinae, we can gain a clearer picture of how the universe evolved over billions of years. This knowledge helps us to answer some of the most profound questions about the origin of life, the nature of the cosmos, and the fate of the universe itself. Looking to the future, the study of Eta Carinae is poised to continue making significant contributions to our understanding of the universe. The next generation of telescopes, including the James Webb Space Telescope, will allow scientists to observe the star system in unprecedented detail, revealing even more about the mechanisms behind its outbursts, the structure of its surrounding nebula, and the fate of the massive stars that inhabit the system. With the advent of new observational technologies and advanced computational models, astronomers are likely to gain even deeper insights into the inner workings of stars like Eta Carinae, ultimately leading to a more comprehensive understanding of stellar evolution. As we continue to explore the mysteries of Eta Carinae, one thing becomes abundantly clear: this star system is a testament to the dynamic and ever-changing nature of the cosmos. It reminds us that even the most well-established scientific theories can be challenged by the discovery of new phenomena, and that the universe is filled with mysteries that continue to defy our understanding. The study of Eta Carinae, with all of its unpredictable behavior and cosmic wonder, is a symbol of the excitement and uncertainty that define the scientific quest for knowledge. The true significance of Eta Carinae lies not just in its individual characteristics, but in what it represents for our understanding of the universe. This star system is a living laboratory, providing a unique opportunity to study the life cycle of massive stars, the dynamics of binary systems, and the processes that govern the evolution of galaxies. Through the continued exploration of Eta Carinae, we are not just learning about one star, but about the fundamental processes that shape the very fabric of the cosmos. And as we unravel its mysteries, we are reminded that there is still so much more to discover in the vast and awe-inspiring universe that surrounds us. As we move forward in our exploration of Eta Carinae and its cosmic mysteries, it's important to understand the broader context of the system's continued relevance. The star has remained a focal point for astronomical research due to the abundance of unanswered questions and its potential to reshape existing models of stellar behavior. By investigating Eta Carinae's extreme characteristics, scientists are not merely studying a single star but engaging in an ongoing process of refining our understanding of how massive stars evolve, interact, and eventually meet their dramatic ends. The stellar phenomena occurring within Eta Carinae also raise broader questions about the fate of other massive stars scattered throughout the universe. For astronomers studying distant stars, systems like Eta Carinae offer a unique opportunity to probe the future behavior of stars similar to it. Eta Carinae is far from being an isolated example of what happens when massive stars enter the final stages of their life cycle. However, due to its relatively close proximity to Earth, approximately 7,500 light-years away, Eta Carinae provides an unprecedented level of detail and clarity, allowing scientists to track the evolution of a massive star with a degree of accuracy that would be difficult to achieve with more distant objects. One of the most intriguing aspects of the study of Eta Carinae is how it challenges our preconceived notions about stellar behavior. Traditionally, astronomers have believed that massive stars undergo relatively predictable changes as they age, with most following a trajectory that culminates in a supernova explosion. However, Eta Carinae has demonstrated that even among the most well-studied stars, there can be significant deviations from the expected patterns. The fact that this system has experienced multiple massive outbursts and continues to exhibit highly irregular behavior suggests that the life cycle of massive stars may be even more complex than previously thought. This has forced astronomers to rethink some of the fundamental principles that govern stellar evolution, potentially leading to new models that can account for these unexpected phenomena. Furthermore, the continued study of Eta Carinae underscores the critical importance of multidisciplinary approaches in unraveling complex cosmic mysteries. The study of stellar evolution involves a combination of theoretical modeling, observational data, and simulations, all of which work together to provide a more complete picture of a star's behavior. While astronomers have made remarkable strides in understanding the fundamental mechanics of stars, Eta Carinae highlights just how much is still left to discover. It demonstrates that even with all of our advanced technology, there are still vast areas of the universe that remain elusive and difficult to comprehend fully. Another compelling facet of the Eta Carinae system is its nebula, the Homunculus Nebula, which is an essential part of the overall narrative of this star's story. The Homunculus Nebula is a vast, complex structure of gas and dust that has been shaped by the powerful outbursts of Eta Carinae. It is one of the most studied nebulae in the sky, largely due to its association with the star and the extraordinary events that have sculpted its shape over time. The nebula is a beautiful but stark reminder of the destructive power of massive stars and their ability to reshape their surroundings. The interaction between the star and the nebula is a direct result of the star's eruptions and acts as a visible record of the energy and matter released during these dramatic events. The study of the Homunculus Nebula is crucial for understanding how mass loss occurs in stars nearing the end of their life cycles. As Eta Carinae expels vast quantities of material into space, the nebula gradually expands outward, growing ever larger and more diffuse over time. This process of mass loss is not limited to Eta Carinae alone. Other massive stars undergo similar stages of evolution, gradually shedding their outer layers as they age. The material expelled by such stars contributes to the interstellar medium, enriching it with the elements necessary for the formation of new stars, planets, and potentially life. In this way, Eta Carinae and its nebula play a fundamental role in the ongoing cycle of star birth and death that governs the evolution of galaxies. Through detailed observations of the Homunculus Nebula, scientists can also gain insights into the conditions that lead to the formation of nebulae in general. By studying the intricate structures within the nebula, including the dense knots of gas and dust that have been shaped by the wind and radiation from the star, astronomers can learn more about the processes that drive the formation and evolution of nebulae. This, in turn, could help to shed light on the mechanisms behind other cosmic phenomena, such as planetary nebulae, which are often formed by dying low and medium-mass stars. Moreover, the Homunculus Nebula serves as a laboratory for understanding the interaction between a star's energy output and the material surrounding it. The intense radiation and stellar winds from Eta Carinae create a turbulent environment, with shocks and ionized gas clouds constantly being stirred up. These high-energy conditions are also seen in other stellar environments, especially those surrounding massive stars. Understanding how nebulae are shaped by these forces can provide clues to the broader mechanisms that govern the behavior of stars and their interactions with their surroundings. While Eta Carinae's periodic outbursts and the formation of the Homunculus Nebula are fascinating in their own right, they also offer important clues about the fate of stars and similar systems across the universe. Massive stars like Eta Carinae are rare but incredibly significant, as their behavior has a profound impact on the galaxies in which they reside. The heavy elements they produce and the energy they release into the surrounding space play a pivotal role in shaping the future of their host galaxies. Understanding how these stars behave, particularly the extreme outbursts that are characteristic of systems like Eta Carinae, helps astronomers to better comprehend the dynamics of galaxies and the formation of new stellar systems. Looking to the future, Eta Carinae remains a source of great intrigue. As new observational technologies, such as the James Webb Space Telescope, come online, astronomers will have the ability to study the star in unprecedented detail. These observations may provide further clues as to the true nature of Eta Carinae's enigmatic behavior, offering deeper insights into its outbursts, its interaction with the surrounding nebula, and its eventual fate. This ongoing research promises to refine our models of stellar evolution and provide new perspectives on the life cycle of massive stars. Eta Carinae's role in the cosmic landscape will undoubtedly continue to evolve as new discoveries emerge, providing an exciting and ever-expanding window into the workings of the universe. The mysteries of Eta Carinae offer a compelling narrative that ties together numerous aspects of astrophysics, from stellar evolution to cosmic enrichment, and the role of massive stars in shaping the universe. This star system, with its explosive outbursts and complex structure, challenges our understanding of the cosmos and forces us to reconsider what we thought we knew about the life cycle of stars. As we continue to study Eta Carinae, we are not only learning about one of the most enigmatic stars in the sky but also gaining crucial insights into the fundamental processes that govern the evolution of the universe itself. As we continue to delve deeper into the enigma that is Eta Carinae, it's important to note that the story of this star system is far from over. In fact, Eta Carinae may have some of the most crucial revelations about the life cycles of massive stars yet to unfold. The star's eccentric behavior challenges even the most advanced models of stellar physics, suggesting that we might still be on the brink of discovering fundamental truths about the universe's most massive objects. In the coming years, advancements in technology may allow us to observe Eta Carinae's every move with greater precision, perhaps allowing astronomers to predict future outbursts or other critical events before they occur. One of the most exciting possibilities on the horizon is the chance to witness Eta Carinae's final act. As it continues to defy expectations with its prolonged life cycle and periodic outbursts, the star might one day meet its end in a way that we have not yet anticipated. While supernovae are the typical fate for massive stars, Eta Carinae's irregular behavior leaves open the question: will it collapse in a traditional explosion, or will it somehow evolve into a different kind of cosmic object? Could this star's ultimate death result in a hypernova or even a black hole? The uncertainty surrounding the ultimate fate of Eta Carinae makes it one of the most thrilling objects for study, as it will likely provide the key to understanding the final stages of stellar evolution for the largest stars in the universe. Moreover, Eta Carinae's role in the broader context of stellar evolution extends beyond its own boundaries. Understanding how stars like Eta Carinae behave offers profound implications for our understanding of the entire universe. Massive stars are responsible for producing heavy elements through the process of nuclear fusion, and when they explode, they spread these elements into the interstellar medium, enriching future generations of stars and planets. The outbursts of Eta Carinae could, therefore, be contributing to the next generation of stars, perhaps even influencing the formation of new planetary systems. By studying the chemical signatures in the material expelled by the star, astronomers can learn about the complex processes that occur in the interiors of stars, including how they synthesize elements and distribute them throughout the universe. These elements, forged in the core of stars like Eta Carinae, become the building blocks for the next stages of cosmic evolution. For instance, the carbon and oxygen produced by these stars can eventually form the basis for the development of life in other parts of the universe. The material that is ejected during stellar outbursts is not only vital for creating new stars and planets, but also for the development of complex structures within galaxies. The gases, dust, and heavy elements from dying stars play an essential role in the ongoing processes of cosmic recycling, helping to shape the formation of future generations of stars and the worlds that may orbit them. The impact of Eta Carinae extends beyond its immediate surroundings in the Milky Way. In a sense, the star is a cosmic laboratory, providing us with the opportunity to test our theories about stellar evolution, supernovae, and the fate of massive stars. Through this lens, Eta Carinae becomes more than just an object of curiosity. It serves as a window into the fundamental processes that govern the universe. By studying this star and others like it, we are uncovering the very nature of the forces that shape the cosmos. Each new observation, each new discovery, brings us one step closer to unlocking the mysteries of how stars live and die, and how these processes drive the evolution of galaxies, solar systems, and potentially, life itself. As technological advancements continue to push the boundaries of what we can observe in space, Eta Carinae is likely to remain one of the most intriguing and influential stars in our galaxy. New instruments like the James Webb Space Telescope, which promises to reveal previously hidden details about distant star systems, could offer unparalleled insights into the nature of this cosmic giant. The combination of advanced infrared and X-ray observations will allow astronomers to examine Eta Carinae in greater detail than ever before, unveiling hidden facets of the star's behavior and structure. One particular area of focus for future research will likely be the complex interplay between Eta Carinae's two primary stars. The binary nature of the system is one of its most unique features, and understanding how these two massive stars interact will be key to understanding the behavior of the system as a whole. How do these stars influence each other through their gravitational pull, stellar winds, and radiation? How do these interactions contribute to the unusual outbursts that have characterized the system? And perhaps most intriguingly, what role will their eventual collision or close encounter play in the ultimate fate of Eta Carinae? These are questions that may take years or even decades to answer fully, but they are crucial for advancing our understanding of the mechanics of binary star systems and the complex processes that govern their evolution. As we observe how Eta Carinae's components evolve over time, we may uncover new aspects of stellar physics that will challenge and refine our models of stellar interaction. The future of this system promises to be filled with exciting discoveries that could radically shift our understanding of how stars behave, particularly in the most extreme environments. Moreover, the continued study of Eta Carinae and similar systems could have broader implications for our understanding of the universe itself. Massive stars like Eta Carinae are believed to play a significant role in shaping the structure of galaxies. The energy and material released by their explosive deaths can influence the dynamics of the surrounding environment, triggering the formation of new stars or even altering the course of galactic evolution. Understanding the life cycle of stars like Eta Carinae may provide clues about the future of our own galaxy and the forces that will shape its destiny. In the search for life beyond Earth, the study of Eta Carinae also holds valuable lessons. While it is unlikely that life as we know it could exist around a star as unstable as Eta Carinae, the conditions surrounding its eruptions and the elements it produces may provide key insights into the types of environments where life could potentially emerge. The study of extreme stellar environments helps to expand our understanding of what makes a planet habitable, and by understanding the behavior of stars like Eta Carinae, we can better determine the likelihood of finding life elsewhere in the universe. The long-term implications of studying such stars extend even further. As humanity looks toward the distant future, seeking to explore other star systems and perhaps even colonize new worlds, understanding the dynamics of stellar life cycles will be critical. The behavior of stars like Eta Carinae could provide valuable insights into the types of environments that future space explorers may encounter. From the potential hazards of nearby supernovae to the processes of star formation that shape entire galaxies, the lessons we learn from Eta Carinae and similar stars could influence the direction of humanity's journey into the cosmos. As we reflect on the significance of Eta Carinae, it becomes clear that this star is not merely a point of fascination for astronomers. It is a key to understanding some of the deepest questions about the nature of the universe. Its explosive history, its role in the life cycles of stars, and its mysterious future all serve to remind us of the vast and unpredictable forces that shape the cosmos. Eta Carinae is not just a star that refuses to die, it is a star that challenges our assumptions, inspires new questions, and offers glimpses of the profound complexities that lie at the heart of the universe. As we continue exploring the mysteries surrounding Eta Carinae, one cannot ignore the potential consequences that this star's final moments may have on its surroundings. The eventual death of Eta Carinae could lead to the birth of even more fascinating cosmic phenomena, shaping the space around it in ways that we are only beginning to comprehend. The energy released from such an event, whether it results in a supernova, hypernova, or even a black hole, could dramatically alter the structure of the interstellar medium in the surrounding region of the Milky Way. To truly understand the profound impact of Eta Carinae's death, one must consider the immense forces at play. The core collapse supernovae of massive stars like Eta Carinae unleash an incredible amount of energy, roughly the equivalent of what the Sun would produce in its entire lifetime. These catastrophic explosions are responsible for spreading heavy elements into the universe, elements that are crucial for the formation of planets, new stars, and even life itself. Eta Carinae, in its final act, will release a shockwave of matter and radiation that could trigger the creation of new stars, enriching the Milky Way with the ingredients necessary for future generations of cosmic evolution. But even more interesting is the possibility that the death of Eta Carinae could result in the creation of a black hole. Given the extreme mass of the star, if it undergoes a supernova explosion, its core could collapse to form a singularity, a point of infinite density. The formation of a black hole from a star like Eta Carinae would add yet another layer of mystery to an already enigmatic system. The sheer gravitational pull of a black hole would warp the fabric of space-time, creating a region from which not even light could escape. The presence of such an object in the heart of the Milky Way would have far-reaching consequences, affecting nearby stars, planets, and the interstellar medium in profound ways. It is also worth considering the broader implications of such stellar deaths across the universe. The death of stars like Eta Carinae is not an isolated event, it is part of a larger process that drives the evolution of galaxies. As stars explode and spread heavy elements throughout space, they play an integral role in the formation of new stars and planets. In this way, the death of Eta Carinae, though a cataclysmic event in its own right, will also be a necessary step in the cosmic cycle of creation and destruction, influencing the next generation of stars that will shape the future of the galaxy. The death of massive stars is also closely tied to the theory of cosmic recycling. The concept of cosmic recycling involves the idea that the material expelled during the death of a star is reused to form new stars, planets, and even life. As Eta Carinae sheds its outer layers, the material it ejects will enrich the interstellar medium with the building blocks necessary for the creation of future stars and planets. This process highlights the interconnectedness of the universe, where every star's life and death contribute to the ongoing evolution of the cosmos. In a sense, stars like Eta Carinae are the architects of the universe, shaping the structure and composition of galaxies through their life cycles. Beyond the realm of stellar evolution, the study of Eta Carinae also has profound implications for the broader field of astrophysics. The unusual characteristics of this star system challenge many of the assumptions we have about the behavior of massive stars, particularly in relation to their outbursts. By studying Eta Carinae, scientists are forced to reconsider and refine existing models of stellar evolution, supernovae, and binary star systems. Eta Carinae's behavior has already led to new insights into the complex interactions between massive stars and binary systems, providing a valuable laboratory for testing our understanding of these cosmic phenomena. Perhaps one of the most compelling aspects of studying stars like Eta Carinae is the window they provide into the processes that govern the life cycles of stars across the universe. While Eta Carinae may be an extreme case, the principles at play in this star's evolution are universal. Every star in the universe undergoes some form of life cycle, from its birth in a molecular cloud to its eventual death. Eta Carinae's dramatic and violent path offers a unique glimpse into this universal process, allowing scientists to gain a deeper understanding of the forces that govern the birth and death of stars. In the search for knowledge about the origins of the universe, studying stars like Eta Carinae is crucial. These stars are not just isolated objects of scientific interest. They are key to understanding the fundamental processes that shape the universe. The fusion processes that occur in their cores, the explosive deaths that end their lives, and the cosmic recycling that follows all play a role in the ongoing evolution of galaxies and the broader universe. As such, stars like Eta Carinae provide essential clues to the origins of the elements that make up everything around us, from the planets to the very atoms that form our bodies. Even as scientists continue to study the star's past and present, Eta Carinae's future remains one of the greatest unknowns in astrophysics. Will it continue to defy expectations and live longer than predicted, or will it finally undergo a massive explosion that reshapes its surroundings? The answers to these questions may not come for years, but when they do, they will provide us with a deeper understanding of the universe and the forces that drive it. In the grand scheme of cosmic history, Eta Carinae's story is far from over. Whether it fades quietly into the dark void of space or explodes in a brilliant flash of light, it will continue to shape the understanding of stellar evolution for generations to come. The legacy of Eta Carinae will live on in the pages of scientific journals, in the minds of astronomers and astrophysicists, and in the very fabric of the universe itself. As we continue to observe and study this extraordinary star, we are reminded that the universe is filled with mysteries that continue to challenge our understanding and inspire our curiosity. The great eruption of Eta Carinae may have only been the beginning of a cosmic tale that will unfold over the course of centuries, revealing new wonders and offering new insights into the mysteries of the cosmos. As the enigmatic Eta Carinae system continues to intrigue astronomers, its journey offers not only a lesson in the fundamental processes of stellar evolution, but also a glimpse into the future of similar stars scattered across the vast expanse of our galaxy. While the Great Eruption may have captured the attention of the scientific community, it represents only a snapshot of the complex dynamics at play within this extraordinary star system. One of the most compelling aspects of Eta Carinae is its position in the heart of the Milky Way. Located approximately 7,500 light-years away in the Carina-Sagittarius arm, this massive star system is situated in an area rich with gas, dust, and young stars. It occupies a region of space that serves as a cosmic nursery, where new stars are born from the remnants of older stars, and remnants of those older stars become the seeds for future generations of celestial objects. The very presence of Eta Carinae, with its immense size and extraordinary energy output, contributes to the dynamics of the surrounding space in ways that we are only beginning to understand. The region surrounding Eta Carinae is itself a remarkable part of our galaxy. Known as the Carina Nebula, this massive star-forming region is home to a variety of hot, young stars that are constantly bombarding their surroundings with radiation and stellar winds. These stars, like Eta Carinae itself, are burning through their fuel at an alarming rate, and their lives will be short but intense. The gas and dust in the nebula, which are constantly being shaped and reshaped by the radiation and winds of these stars, form a dynamic, ever-changing environment. As the most massive and luminous star in this region, Eta Carinae plays a pivotal role in shaping the characteristics of the nebula and influencing the formation of new stars. As the Carina Nebula is constantly evolving, Eta Carinae serves as both a source of energy and a catalyst for the creation of new stars. When Eta Carinae eventually reaches the end of its life and undergoes its final explosive death, it will send shockwaves through the nebula, triggering the formation of new stars. The explosion will release enormous amounts of energy, pushing gas and dust into regions of space where it can collapse under its own gravity to form new stellar bodies. In this way, Eta Carinae's death will contribute to the ongoing cycle of star formation in the galaxy, ensuring that the legacy of massive stars continues to shape the interstellar medium for billions of years to come. The broader implications of Eta Carinae's eventual demise extend far beyond the immediate region of the Carina Nebula. The heavy elements that will be released in the star's death, including oxygen, carbon, and nitrogen, are critical components for the formation of planets and life. These elements, forged in the cores of massive stars, are scattered throughout the universe in the wake of supernova explosions. As Eta Carinae's explosive death sends its enriched material across space, it will contribute to the creation of new planetary systems and potentially even life-bearing planets. In this way, the star will play an indirect yet profound role in the ongoing evolution of the universe. While scientists have been able to observe the Great Eruption and study the star's behavior in detail, there is still much to learn about the nature of such massive stars and the forces that drive their extraordinary behavior. For decades, astronomers have been puzzled by the mechanisms that trigger these intense outbursts, and how stars like Eta Carinae manage to survive such cataclysmic events. Despite the violent outbursts, Eta Carinae has shown remarkable resilience, surviving the Great Eruption and continuing to shine brightly in the sky. The reasons behind its ability to withstand such forces remain a mystery, and understanding this phenomenon could provide critical insights into the dynamics of massive stars and their behavior at the end of their lives. One potential explanation for Eta Carinae's resilience lies in its binary nature. As a member of a binary star system, Eta Carinae's interaction with its companion star could be influencing its behavior. Binary systems, in which two stars orbit around a common center of mass, often exhibit complex dynamics that can affect the evolution of the individual stars. In the case of Eta Carinae, its massive companion could be contributing to the star's outbursts and providing additional energy that allows it to continue shining long after it would have otherwise burned out. The interaction between the two stars in the system could also be responsible for the formation of the massive, turbulent nebula that surrounds them, creating a feedback loop that perpetuates the system's energetic activity. The study of binary systems like Eta Carinae is crucial for understanding the behavior of massive stars. Binary systems are relatively common in the universe, and many of the most luminous and massive stars we observe are part of such systems. Understanding how these systems evolve and how their components interact is key to unlocking the mysteries of stellar evolution, particularly in relation to the formation of supernovae, black holes, and other exotic objects. While Eta Carinae may be one of the most famous examples of a massive, unstable star system, it is by no means unique. Across the universe, other massive stars are undergoing similar processes, burning through their fuel at an alarming rate and preparing for eventual explosions. Eta Carinae serves as a valuable case study for understanding the broader behavior of these stars and the forces that govern their evolution. By studying Eta Carinae and similar systems, scientists are gaining insights into the processes that drive the creation and destruction of stars, as well as the impact these events have on the surrounding universe. As we continue to learn more about Eta Carinae and its behavior, the mysteries surrounding this star system will undoubtedly lead to new breakthroughs in astrophysics. The extreme conditions present in this system, massive stars, intense radiation, and violent outbursts, offer a unique laboratory for testing our theories of stellar evolution, supernovae, and the formation of exotic objects. The eventual death of Eta Carinae, whenever it occurs, will provide an even more fascinating opportunity for scientific discovery, offering new insights into the processes that govern the end stages of massive stars and the creation of black holes, neutron stars, and other cosmic phenomena. In the grand narrative of the universe, the story of Eta Carinae is one of both creation and destruction, a reminder of the constantly shifting forces at play in the cosmos. As the star continues its unpredictable journey through space, scientists will undoubtedly remain captivated by its mystery, eagerly awaiting the next chapter in its cosmic tale. Whether Eta Carinae ultimately explodes in a burst of energy, or continues to surprise us with its resilience, it will forever be etched in the annals of astronomy as one of the most intriguing and enigmatic objects in the universe. As we peer deeper into the unfolding story of Eta Carinae, it's important to realize that the star system is not merely a curiosity, but a key to understanding the larger mechanisms that govern the lives of stars. The massive scale of the eruption and the complexity of its interactions with its companion star offer rare insights into the most extreme environments in the universe. Eta Carinae's role as a powerful star in a binary system, with its massive companion star, provides us with the perfect setting to study how these massive systems evolve. The binary interaction significantly influences the behavior of these stars, as it can lead to the transfer of mass from one star to the other, altering the trajectory of their lives. Such mass transfer can lead to a variety of phenomena, including the triggering of outbursts like the Great Eruption, and it could explain the dynamic and ever-changing nature of the system. In fact, the mass exchange between the two stars in the Eta Carinae system may be responsible for the periodic nature of its outbursts. One theory suggests that the companion star's intense radiation and stellar wind may be contributing to the buildup of material around Eta Carinae, which then undergoes dramatic ejections. The interaction of these two stars could also be shaping the nebula that surrounds them, creating a visually stunning environment of gas and dust. It is possible that this binary relationship is influencing the system's stability, enabling Eta Carinae to survive longer than it might otherwise have, though the star is ultimately doomed to explode. As the system evolves, the end of Eta Carinae's life will not be a quiet affair. When the star finally exhausts its nuclear fuel, it is expected to end its life in a massive explosion, a hypernova or a gamma ray burst, that will leave behind an extraordinary remnant. Such events are not merely spectacular, they play an important role in shaping the universe. The immense energy released during such an explosion will be responsible for the formation of heavy elements like gold, platinum, and uranium, elements that are essential to the creation of planets, asteroids, and other celestial bodies. This process, known as nucleosynthesis, is a vital component of the life cycle of stars, and Eta Carinae's eventual death will contribute to the cosmic recycling of matter, seeding the next generation of stars and planetary systems. The Great Eruption of Eta Carinae provides a unique opportunity to study such processes in real time. Unlike the death of stars that occurs on much longer time scales, the outbursts of Eta Carinae are relatively recent and observable. This allows astronomers to witness firsthand the dramatic consequences of stellar evolution, providing invaluable data about the mechanisms that govern the transformation of stars into explosive events. Such observations also allow scientists to refine models of star behavior, helping us better understand the ultimate fate of other massive stars in our galaxy and beyond. Yet, despite the immense advances that have been made in our understanding of Eta Carinae, many questions remain unanswered. For example, what exactly caused the Great Eruption in the first place? Was it the result of the interaction between the two stars in the binary system, or was it the product of internal instabilities within Eta Carinae itself? Understanding the triggers of such outbursts is crucial for improving our models of stellar behavior, and Eta Carinae offers an unprecedented laboratory for testing these theories. Another mystery revolves around the nature of the companion star itself. While it is clear that the star system is composed of at least two massive stars, the exact characteristics of the companion star are still not fully understood. Is it a massive, bright star like Eta Carinae, or is it smaller and less luminous? Does the companion star play a significant role in triggering the outbursts, or is it simply a bystander in the chaos of Eta Carinae's evolution? These are questions that astronomers are actively working to answer, and each piece of the puzzle brings us closer to a complete understanding of how such massive star systems evolve. One of the most fascinating aspects of Eta Carinae is the way its behavior challenges our preconceived notions of stellar life cycles. For decades, astronomers assumed that stars like Eta Carinae would follow a predictable path, gradually using up their fuel and then exploding as supernovae. However, the Great Eruption upended these expectations, showing that such stars are capable of undergoing dramatic outbursts long before reaching the end of their lives. This discovery has forced scientists to reconsider their models of stellar evolution and prompted a reassessment of how massive stars behave in their final stages. This newfound understanding of stellar instability has profound implications for the study of other massive stars across the galaxy. Eta Carinae is not an isolated example but rather a representative of a class of stars that may share similar characteristics and behaviors. As astronomers continue to observe and study other massive stars, they will be able to refine our understanding of the processes that drive these outbursts, and ultimately lead to the death of these cosmic giants. The more we learn about stars like Eta Carinae, the better we will be able to predict the fates of similar stars throughout the universe. The study of massive stars like Eta Carinae is also crucial for understanding the broader dynamics of galaxies. Massive stars are often responsible for the creation of the elements that make up planets and life as we know it. As these stars explode in supernovae or hypernovae, they scatter these elements throughout the galaxy, enriching the interstellar medium and contributing to the formation of new stars, planets, and even life itself. In this sense, stars like Eta Carinae are not just important for understanding the life cycles of individual stars but also for understanding the processes that shape the evolution of galaxies. Eta Carinae's explosive potential offers a glimpse into the future of the universe itself. The star's eventual death, and the subsequent release of energy and material, will trigger a cascade of events that will impact the surrounding region of space for millions of years to come. While this may seem like a distant event, it serves as a reminder that the universe is constantly evolving, with stars being born, living, and dying in a never-ending cycle that shapes the very fabric of reality itself. In the context of the broader cosmic narrative, Eta Carinae stands as a testament to the incredible forces at work in the universe. Its violent outbursts, massive size, and eventual demise will continue to provide valuable insights into the nature of stars, the formation of elements, and the evolution of galaxies. As our understanding of this star system deepens, we are not only uncovering the mysteries of one of the most remarkable objects in the sky but also learning more about the fundamental processes that govern the universe. Eta Carinae is much more than just a star system. It is a cosmic laboratory, a source of fascination and wonder, and a key to unlocking the mysteries of stellar evolution. Through its incredible outbursts, its complex binary relationship, and its eventual death, Eta Carinae provides a unique opportunity to study the forces that shape the universe. While the star's fate is still unfolding, its story has already provided us with invaluable insights into the nature of the cosmos, and it will continue to inspire scientific inquiry for generations to come. As we continue to unravel the mysteries surrounding Eta Carinae, it becomes increasingly clear that its significance extends far beyond its own demise. The insights we gain from studying this enigmatic system are likely to influence many aspects of astrophysics and our understanding of the universe. One of the most profound lessons we can take away from Eta Carinae is the realization that there is much we still do not know about the life cycles of massive stars and the complex relationships between stellar objects. One of the most striking features of the Eta Carinae system is the way in which its massive outbursts challenge the traditional theories of stellar behavior. Stellar models have long suggested that massive stars go through a relatively predictable series of stages, evolving from the main sequence, to red giant, to supernova. However, the great eruption of Eta Carinae defied these expectations, leading astronomers to reconsider the models they had relied on for so long. The eruption did not fit neatly into the usual pattern of stellar evolution, which suggests that there may be additional processes at work that we have yet to fully understand. In many ways, Eta Carinae is forcing scientists to rethink the way we conceptualize the life cycles of stars. Instead of following a neat, linear progression, some stars, especially those in binary systems, may experience sudden, dramatic changes that disrupt the normal course of their evolution. The outbursts of Eta Carinae, therefore, may not be an anomaly but a natural feature of certain types of massive stars. This opens the door to new models of stellar evolution that account for the possibility of extreme fluctuations in a star's behavior, particularly in systems where stellar companions are involved. The binary nature of Eta Carinae has proven to be a crucial factor in the star's unique behavior. While single stars do indeed undergo dramatic changes at the end of their lives, the relationship between the two stars in a binary system introduces a whole new layer of complexity. The mass exchange between the stars, the interaction of their stellar winds, and the gravitational forces at play all contribute to the dynamic environment in which these stars exist. Eta Carinae's companion star plays an integral role in shaping the system's overall behavior, and understanding the interactions between these two stars will be key to unlocking the full mystery of the system. The role of binary interactions in the formation of nebulae and other cosmic structures is also a critical aspect of Eta Carinae's legacy. The outbursts from Eta Carinae are not just spectacular in themselves but have far-reaching consequences for the surrounding environment. The material expelled during the eruptions has contributed to the creation of the nebula that surrounds the star system, known as the Homunculus Nebula. This nebula is a stunning example of the way in which massive stars shape the interstellar medium, enriching the space around them with gas, dust, and heavy elements. The nebula itself serves as a testament to the energy and power that is released during such outbursts, creating a complex and visually striking structure that will continue to evolve for millions of years. The study of such nebulae is vital for understanding the processes that drive the formation of new stars and planetary systems. The material expelled by Eta Carinae and other similar stars is responsible for enriching the interstellar medium, providing the raw materials for the next generation of stars. This process of cosmic recycling is essential for the continued evolution of galaxies, as it ensures that the elements necessary for life are constantly being replenished and distributed throughout the universe. The Homunculus Nebula, as a product of Eta Carinae's explosive outbursts, serves as a living laboratory for the study of this cosmic cycle. The eruption of Eta Carinae also challenges our understanding of the role of mass in stellar evolution. Eta Carinae is an extremely massive star, and the dynamics of such massive stars are still not fully understood. We know that massive stars burn through their fuel at an astonishing rate, often living only a fraction of the time that less massive stars do. But the fact that Eta Carinae has undergone such dramatic outbursts and still continues to shine brightly today suggests that the mechanisms driving its evolution are more complex than we had previously realized. In fact, the study of Eta Carinae may eventually provide answers to some of the most fundamental questions in astrophysics. How do massive stars behave in the final stages of their evolution? What triggers the dramatic outbursts seen in certain stars? How do binary interactions influence the evolution of stars? And what role do they play in the formation of nebulae and other cosmic structures? These are questions that astronomers continue to explore, and the answers they uncover may revolutionize our understanding of stellar evolution and the fate of the most massive stars in the universe. Furthermore, Eta Carinae's eventual explosion as a hypernova or gamma ray burst will mark the end of an era for this remarkable star system. While the star's ultimate demise is still many millions of years away, the implications of such an event are profound. The release of energy and heavy elements during such an explosion will have a lasting impact on the surrounding region of space, triggering the formation of new stars and planetary systems. The energy from the explosion will also travel across the galaxy, possibly even influencing the evolution of other stars and planets far beyond the immediate vicinity of Eta Carinae. This process of cosmic recycling is essential for the continued evolution of galaxies and the life cycles of stars. The heavy elements created in the cores of massive stars like Eta Carinae are dispersed throughout the galaxy during supernovae, enriching the interstellar medium and providing the building blocks for the next generation of stars and planets. These elements, such as carbon, oxygen, and nitrogen, are the very building blocks of life as we know it. Without the violent deaths of massive stars like Eta Carinae, the universe would not have the necessary elements to support life. In this way, Eta Carinae's explosive fate serves as a reminder of the interconnectedness of all things in the universe. The life cycle of stars is a never-ending cycle of creation and destruction, and every star that dies contributes to the ongoing evolution of the cosmos. Eta Carinae, with its stunning outbursts, massive size, and eventual death, is a powerful symbol of the forces that shape the universe. Its story is not just one of a single star system but a reflection of the broader cosmic narrative that unfolds across the galaxy and beyond. As we look to the future, Eta Carinae will continue to be a subject of fascination and study for astronomers and astrophysicists. Its unique characteristics, dramatic outbursts, and eventual explosion offer an unparalleled opportunity to study the forces at work in some of the most extreme environments in the universe. And as our understanding of this star system deepens, we are likely to gain new insights into the fundamental processes that govern the evolution of stars, galaxies, and the universe itself. The great eruption of Eta Carinae and the ongoing study of this remarkable star system remind us of the awe-inspiring power and complexity of the universe. The events unfolding in this distant corner of the cosmos are not just of academic interest but serve as a testament to the vastness and mystery of the universe. The story of Eta Carinae is one that continues to unfold, and as we study it, we are not only learning more about the nature of stars but also about the very forces that have shaped the universe from the very beginning. The mystery of Eta Carinae does not end with its incredible outbursts and eventual demise. It also holds potential insights into the broader processes that govern the formation of stars and galaxies. The behavior of Eta Carinae, particularly its interaction with its companion star and the resulting eruptions, can provide valuable lessons about the dynamics of massive stars, the impact of stellar winds, and the role of binary systems in the evolution of stars. It is important to understand that while Eta Carinae is a very extreme case, its study helps scientists refine their models of stellar evolution. In particular, binary star systems like Eta Carinae may not be as rare as once thought, and many stars in our galaxy and beyond could exhibit similar outbursts. The close interaction between two massive stars in such systems creates a turbulent environment in which mass is transferred from one star to another, altering their fates in dramatic ways. This mass transfer not only leads to powerful outbursts but also influences the luminosity, size, and eventual end stages of each star. One of the biggest mysteries surrounding Eta Carinae's explosive behavior lies in the details of the mass transfer between the two stars. The primary star in this system is so massive that it would burn through its nuclear fuel much faster than smaller stars, leading to a rapid progression through its evolutionary stages. The companion star, although much less massive, plays an essential role in shaping the system's overall evolution. Through the interaction of their stellar winds and the transfer of material between the two stars, Eta Carinae has defied expectations and demonstrated a more chaotic and irregular evolution than we would have anticipated from typical massive stars. The sheer scale of the Great Eruption also raises questions about the underlying mechanisms of such violent outbursts. While some massive stars exhibit predictable behaviors, the behavior of Eta Carinae is unpredictable and dramatic. Why does this star system erupt in such an erratic manner? One possibility is that the transfer of mass between the two stars could be responsible for the instability that leads to these massive explosions. In this model, the accumulation of material on the primary star's surface creates a sudden imbalance, causing the star to eject enormous amounts of gas and dust in a spectacular eruption. Another possibility is that the star experiences intermittent bursts of instability due to the intense gravitational interactions between the two stars. Eta Carinae's behavior also underscores the importance of studying star systems in their entirety rather than focusing solely on individual stars. The interaction between stars and binary systems can profoundly influence their evolution, often in ways that are difficult to predict. Understanding these interactions is crucial not only for understanding Eta Carinae but also for expanding our understanding of the life cycles of massive stars across the universe. The study of binary systems may reveal that many stars exhibit behaviors that were once considered anomalies, and Eta Carinae may be just one example of a broader class of stellar phenomena that scientists are still working to understand. Moreover, the insights gained from Eta Carinae's violent outbursts and its eventual death will have broader implications for understanding the death of stars in general. For example, when Eta Carinae eventually explodes in a hypernova or gamma ray burst, the energy released will dwarf that of a typical supernova. This event will likely produce a wealth of new elements, some of which could play a role in the formation of new stars and planets. But it will also have consequences for the surrounding interstellar medium. The intense radiation and shockwaves produced during such an event can trigger the formation of new stars and reshape the local environment in profound ways. The concept of stellar recycling becomes even more poignant when we consider that the energy and materials from such cataclysmic events may eventually give rise to new stars, planetary systems, and potentially even life. Every massive star that dies in such an explosive manner contributes to the ongoing cycle of star birth and death in the galaxy. Without these enormous stellar outbursts, the universe would be missing many of the heavy elements required for the formation of life as we know it. Eta Carinae's impending death, however far off it may be, represents a significant event in the broader cosmic cycle. The star's violent eruption will not only mark the end of its life but will also serve as a catalyst for the birth of new stars and planets in the surrounding space. This process is a reminder that the universe is constantly evolving, with the death of one star giving way to the birth of another. It is this eternal cycle that shapes the very fabric of the cosmos. In addition to its role in the formation of stars, Eta Carinae's violent behavior and eventual explosion will also offer insights into the study of high-energy astrophysics. The radiation emitted during its outbursts and final explosion will be studied by astronomers using a variety of instruments, from optical telescopes to space-based gamma-ray detectors. This data will provide valuable information about the physical conditions in the heart of massive stars, the behavior of stellar winds, and the processes that govern the formation of black holes and neutron stars. Eta Carinae, therefore, offers a unique opportunity to study some of the most extreme phenomena in the universe. One of the most intriguing aspects of studying Eta Carinae is the way in which it challenges our understanding of time and space. The outbursts that occur in this system take place over timescales of thousands of years, far longer than a human lifetime. However, the events themselves are happening at such extreme distances that the light from these eruptions takes many years to reach us. This delay means that what we are observing today may not be the true current state of Eta Carinae, but rather a snapshot of the system as it existed in the past. The star system's past behavior could provide us with clues about its future fate, but we will never be able to directly observe its final moments until much later in time. In this way, Eta Carinae offers a glimpse into the vast timescales of the universe and the cosmic events that unfold on timescales far beyond our own. The phenomenon of Eta Carinae underscores how limited our understanding is of the universe's most extreme environments. Despite our best efforts to model stellar evolution, phenomena like the Great Eruption remind us that the cosmos is far more complicated and unpredictable than we can fully comprehend. The forces at play in these stellar systems are so vast and powerful that even the most advanced scientific theories often fall short in explaining their behavior. Perhaps the most captivating aspect of Eta Carinae's story is that it reminds us of the sheer scale and complexity of the universe. We are witnessing only a small fragment of the story of this star system, and as our technology improves, we will no doubt uncover more about its mysteries. The study of stars like Eta Carinae, with their extreme conditions and powerful outbursts, allows us to peer deeper into the workings of the universe and to better understand the fundamental forces that shape the cosmos. Ultimately, Eta Carinae represents a cosmic riddle that has captivated astronomers for centuries. It is a star system that refuses to die, continually defying expectations and offering new insights into the life cycles of the most massive stars. As we continue to study this incredible star system, we can only imagine the many secrets it still holds and the new discoveries that await us. The story of Eta Carinae is far from over, and as it continues to unfold, it will undoubtedly provide even more profound revelations about the universe in which we live. Eta Carinae is an emblematic example of how the cosmos constantly challenges our understanding, presenting phenomena that push the limits of our current knowledge. What's truly remarkable about Eta Carinae is that it embodies the intersection of two key areas of astronomical research: stellar evolution and the violent events that occur when stars near the end of their lives. While we've discussed the violent outbursts and the enigmatic nature of the star, it's important to address how these massive stars, such as Eta Carinae, are formed and what role they play in the overall structure of galaxies. Massive stars like Eta Carinae don't just live a brief and violent life. Their birth, evolution, and eventual death are crucial for seeding the universe with heavy elements like carbon, oxygen, and iron that form the building blocks of planets, and potentially life, as we know it. The formation of these massive stars begins in vast molecular clouds, which are dense regions of gas and dust in galaxies. These clouds are the nurseries of stars, where gravity pulls together the particles of gas and dust until they collapse inward, forming protostars. However, the formation of a star like Eta Carinae is far from simple. In fact, the process of creating such a massive star is a delicate dance between gravity and radiation pressure. As the protostar heats up and begins nuclear fusion, its core generates massive energy. This radiation pressure pushes outward, counteracting gravity's pull. Only when gravity becomes strong enough to overcome this outward pressure do we see the formation of a true massive star. Eta Carinae itself is a prime example of a star that has experienced this intense and complex birth. It is a member of the class of stars known as Wolf-Rayet stars, which are stars that have lost a significant amount of their outer layers due to the immense radiation pressure at their cores. These stars burn through their nuclear fuel incredibly fast, leading to shorter lifespans compared to lower-mass stars. In fact, the fact that Eta Carinae has survived for as long as it has, surviving multiple outbursts, makes it even more remarkable. However, what sets Eta Carinae apart from other massive stars in the Milky Way is its interaction with its binary companion. As previously mentioned, Eta Carinae is part of a massive binary system, and this relationship is central to its erratic behavior. The gravitational interactions between the two stars result in the transfer of mass from one star to the other, which leads to an unstable, dynamic system. The primary star, being the more massive of the two, is responsible for the majority of the energy output, but the secondary star plays an important role by influencing the overall dynamics of the system. The Great Eruption itself, occurring roughly 170 years ago, was likely triggered by this complex interaction. As mass transferred between the stars, the increased pressure on the surface of the primary star caused it to expel huge amounts of material into space. The eruption released vast quantities of gas and dust, altering the appearance of the star system significantly. This mass loss is thought to have been a key moment in the star's life, indicating that it may be on a trajectory toward an eventual supernova or hypernova explosion. Given the unpredictable nature of the eruptions and outbursts, the study of Eta Carinae has provided new avenues of research into the behavior of massive stars, and specifically, how these stars may end their lives. The Great Eruption was not just an anomaly, it provides a critical clue in understanding the unstable nature of massive star systems and how they may evolve under extreme conditions. Scientists believe that Eta Carinae's eventual fate will include a final dramatic outburst, one that could be one of the most powerful events in the Milky Way. The death of Eta Carinae will not be quiet, it will serve as one of the most violent displays of cosmic power, shedding light on the processes that govern stellar collapse and formation. This leads us to the inevitable question: what exactly will happen when Eta Carinae finally dies? While the exact mechanism of the star's death remains uncertain, it is widely expected that it will end in a supernova or even a hypernova. A supernova occurs when a massive star runs out of fuel in its core, causing its core to collapse under gravity. This collapse triggers a massive explosion that disperses heavy elements into space, enriching the surrounding interstellar medium and potentially triggering the formation of new stars. Eta Carinae, being one of the most massive stars in the galaxy, may end its life in a more exotic and violent manner. A hypernova, an even more powerful explosion than a supernova, could result from the collapse of its core. The energy released in a hypernova would be orders of magnitude greater than that of a typical supernova, and the resulting shockwaves would propagate across vast distances, reshaping the surrounding region of space. If Eta Carinae does indeed undergo a hypernova explosion, it would mark the end of a star that has spent millions of years defying the typical lifespan of most stars. The explosion of Eta Carinae, however, will not just be a spectacular event for observers here on Earth. It will have far-reaching effects on the surrounding regions of the galaxy. The ejected materials will expand outward, creating a vast nebula that could serve as a nursery for future stars and planets. This process of stellar death and rebirth is part of the larger cycle of star formation and destruction that has been occurring throughout the history of the universe. Stars like Eta Carinae are responsible for enriching the interstellar medium with the heavy elements that are necessary for the formation of planets and the emergence of life. In the grand scheme of cosmic evolution, Eta Carinae's death will not be the end of the story. Instead, it will be the beginning of something new. The energy and materials released during its death will fuel the formation of new stars, planetary systems, and potentially life. The death of massive stars is a necessary component of the cosmic cycle, contributing to the continuous regeneration of the universe. Furthermore, the study of such extreme events will continue to refine our understanding of the universe's most violent processes. As technology improves, we may gain even more insight into the complex interactions between massive stars, the nature of stellar winds, and the mechanisms behind stellar outbursts and explosions. Eta Carinae will remain a key object of study for astronomers, offering unique opportunities to learn more about the fundamental forces that shape the universe. In a way, the story of Eta Carinae is not just the story of a single star but the story of the cosmos itself. It is a story of creation, destruction, and rebirth, where the death of one star leads to the birth of another. This eternal cycle of star formation and death is the driving force behind the evolution of galaxies, star systems, and planets. Eta Carinae may be one of the most dramatic and extreme examples, but it is far from unique. Every star, whether it ends its life in a supernova or a more peaceful transition into a white dwarf, plays a part in the cosmic symphony. And so, the study of stars like Eta Carinae serves not only to answer questions about the individual star but also to unlock the secrets of the universe's largest-scale processes. Each observation, each discovery, brings us one step closer to understanding the intricate dance of forces that govern the birth, life, and death of stars across the cosmos. The mystery of Eta Carinae will continue to inspire scientists, astronomers, and space enthusiasts for years to come. Its fiery outbursts, its strange and erratic behavior, and its eventual explosive death will be part of a cosmic tale that has no end, only new chapters to explore. As long as we continue to look to the stars, the legacy of Eta Carinae will remain a powerful reminder of the incredible and mysterious forces that shape our universe. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.